So let's get started. We will be building an Android application and we have named it Cachewise. Throughout the series, you will learn various things such as building scalable app to handle growth seamlessly, whether it uses features or functionality. Build UI components once and reuse them across your app for consistency and faster development. We will add a data visualization layer to app with beautiful graphs and charts. We will use Firebase authentication and analytics to gain insights into user behavior. We will also learn about RoomDB and data stores to efficiently manage apps data. Application codebase will be structured in multi-module architecture, and throughout the video series, we will try to follow the clean coding practices. But that's not all. We will also focus on flexibility and rapid iteration using agile methodology to deliver incremental improvements. We will understand how to manage code changes by following a structured branching strategy. Also, we will see how to automate the build and deployment process using GitHub workflows, ensuring faster delivery with fewer errors. And finally, what are feature flags and why you should use them without disrupting the release process and main application. At the core, these principles drive better collaboration, faster iterations, and more robust delivery pipelines. Mastering these areas will enhance both team productivity and project outcomes. Incorporate choosing a methodology, streamline work, and create a clear structure which provides guidelines for how teams collaborate, prioritize tasks, and deliver results. It ensures everyone is on the same page, minimizes chaos, and helps the organization operate more efficiently. The key is finding what works best for your team's needs and sticking to it. Waterfall is a linear and sequential approach to project management. It is characterized by distinct phases that must be completed one after the other. Typical phases are requirement gathering, where all the project requirements are catered at once, after which you work on the design requirement. Once designs are finalized, you develop the code for the product, which in later stages are sent to QA for verification. And last is the delivery or maintenance phase. While practical, this approach had some major challenges. This approach is inflexible to any change in requirement, making it difficult to accommodate any new changes. Testing, on the other hand, is after the implementation, which could delay the discovery of significant bugs. On the other hand, Agile is an iterative and incremental approach that overcomes the inflexibility and feedback loops. Agile can be achieved by various methodologies like Scrum and Kanban, which focus on delivering small functional pieces of the project in shorter intervals. These deliverables are then tested by the testing team. Any bugs found during this phase are fixed instantly based on the priority or severity. In an Agile team structure, while the core roles remain consistent, the team setup can vary based on factors such as feature teams, component teams, or cross-functional teams. The key roles in any Agile team include stakeholders, the primary decision-makers who provide direction and feedback. Product owner, responsible for defining the product vision, managing the backlog, and prioritizing features based on stakeholder input to maximize value. Scrum master, a facilitator who ensures the team adheres to agile practices, removes impediments, and helps the team work efficiently. Development team, a cross-functional group that includes developers, testers, designers, and back-end engineers, all collaborating to deliver high-quality products. This structure ensures that agile teams remain flexible and adaptive while maintaining a clear focus on delivering value. When following agile practices, teams foster collaboration and communication by participating in various meetings. These meetings are carefully planned to ensure smooth progress and alignment throughout the sprint cycle. There are primarily 5 types of meetings that take place during a sprint. Before the sprint begins, the team selects items from the product backlog, prioritized by the product owner, and estimates the effort required. Factors like team availability, past performance, and capacity help decide how much work can be included in the sprint. Once the sprint begins, a daily stand-up is held, typically lasting 15 minutes. During this meeting, each cross-functional team member answers 3 key questions. 1. What did I accomplish yesterday? 2. What will I work on today? 3. Are there any blockers? This ensures everyone stays aligned and any issues are addressed promptly. Next is the sprint review meeting, held at the end of the sprint. Team members showcase the completed work to stakeholders, providing an opportunity for feedback. This ensures the product stays aligned with stakeholder expectations and requirements. After that, we have the sprint retrospective, where the team discusses what went well and what could have been improved during the sprint. This process helps identify flaws and area for improvement, ensuring better performance in future sprints. Lastly, we have the backlog refinement, a session where the team and the product owner review and refine the product backlog. During this meeting, they clarify new requirements, break down larger tasks, and ensure backlog items are well-defined and ready for future sprints. Based on priority and stakeholder needs, the backlog is reordered to reflect the most important tasks. Next, let's explore the different branching strategies commonly used in organizations. In software development, selecting the right branching strategy is essential for maintaining a smooth and efficient workflow. The two most popular strategies are trunk-based development and Git flow. Each approach has its own advantages, and the choice between them depends on the team structure and project requirements. Trunk-based development encourages developers to commit small, incremental changes multiple times a day. This approach helps reduce merge conflicts and ensures faster feedback loops. With fewer branches to manage, the workflow becomes more streamlined, making collaboration within the team much easier. An essential aspect of trunk-based development is the use of feature flags, which allow incomplete or experimental features to be safely integrated without impacting production. On the other hand, the Git workflow relies on multiple branches for features, bug fixes, and releases. This allows developers to work in isolation, minimizing the risk of bugs being introduced into the main code base. By using dedicated release branches, the team can better control the deployment process, ensuring stability and smoother rollouts. Let's take a closer look at both workflows, starting with trunk-based development. In this approach, the main or master branch serves as the central integration branch. It is always deployable and protected by rules to maintain stability. Developers either work in short-lived branches or commit directly to the main branch, depending on team practices. Developers commit frequently, typically several times a day, and ensure their changes are integrated back into the main branch within 1 to 2 days. This minimizes branch divergence and reduces the risk of complex merges. A key enabler of this approach is the use of feature flags, which allow teams to deploy code without exposing unfinished or risky features to end users. Before merging, changes undergo automated tests, unit and integration, and code reviews to ensure branch stability. Once the changes pass all checks and are approved, they are merged into the main branch. For planned releases, such as at the end of a sprint, a temporary release branch may be created for UAT, user acceptance testing. In many trunk-based workflows, however, both UAT and bug fixes are handled directly on the main branch. Once the release is finalized and tested, the app is deployed to production, and a version tag, example, version 1.0, is assigned to the release commit. If a bug is found in production, it is fixed on the main branch. The fix may also be cherry-picked to a release branch if one exists, resulting in a patched release, example, version 1.1. This workflow promotes frequent integration, rapid delivery, and streamlined collaboration, making it ideal for teams practicing continuous delivery. In contrast, let's explore the Git flow branching strategy. The Git flow workflow involves multiple branches, each with a specific purpose. Main branch reflects the production-ready state of the project. Develop branch acts as the integration branch for ongoing feature development. All feature branches are created from and merged back into the develop branch. When a release is planned, a release branch, example, release version 1.0, is created from develop. On the release branch, only bug fixes, minor improvements, or documentation updates are made. After user acceptance testing is complete, The release branch is merged into both main and develop, ensuring all updates are integrated. A release tag, example, version 1.0, is added to the main branch to mark the production release. If a bug is found in production, a hotfix branch, example, hotfix version 1.1, is created from the main branch. The bug is fixed, and the hotfix branch is merged into both main and develop to keep all branches up to date. A new tag, example, version 1.1, is added to the main branch to represent the patch release. This strategy ensures a structured approach to development, supporting clear workflows for features, releases, and hotfixes. If you're enjoying this video, don't forget to subscribe to our channel and share it with friends who are just starting their journey in software development or are currently studying at university. Your support helps us create more valuable content for learners like you. Now, let's take a look at Jira and how this tool can be used in software development. While setting up a Jira board is typically not your responsibility, it's important to understand how it works for your knowledge. You can log in or sign up at atlassian.com using your Google, Microsoft, or Workplace email account. I'll quickly set up the account using our Workplace email and continue from there. Once you've signed in successfully, you can set up your site by giving it a unique name to identify your workspace. Next, select a template. You can choose any template as it can be changed later. For our use case, we'll select Scrum and click Continue. The workspace will now be set up, which might take a few seconds to complete. Let's set up our first project in Jira, and we'll call it Cashwise. Start by clicking on Create Project from the Jira dashboard. Jira provides a variety of templates tailored for different use cases, which are categorized for easy selection. For this project, we'll select the software development category and choose the Scrum template. Next, you'll need to choose the project type. In this case, we'll go with the team-managed option, as it offers a simpler and more focused setup for smaller teams. Once you've made your selection, click Continue to proceed. Now, let's provide the project details. Start by entering the project name, which in our case will be Cashwise. Then, set the project key, a unique identifier used for issue IDs. For this project, let's use CW as the key. This means all issues created within the project will have IDs like CW1, CW2, and so on. You'll also need to select the access level for your project. Options include Open, where anyone in your Jira instance can access and create issues, or Limited, where only specific team members have access. Choose the level that works best for your team. After entering these details, continue with the default settings unless specific customizations are required. Once everything is completed, click Create, and Jira will take you to your new project's dashboard. This dashboard is your central hub for managing the project, including backlogs, sprints, and reports. Now, let's explore how to add apps to enhance your Jira experience. First, head over to the Apps section in the menu. From here, click on Find New Apps. This will take you to the Atlassian Marketplace, where you can browse a wide variety of integrations. In the search bar, type GitHub for Jira and select the official app. Click on Get App to start the installation process. During the setup, you'll be prompted to authorize Jira to access your GitHub repositories. Simply log into your GitHub account, grant the required permissions, and let Jira establish the connection. Once the connection is successful, you'll see a progress screen as Jira begins syncing your repositories. In just a few moments, all the connected repositories will appear on this configuration page. And it's not just GitHub. Jira supports many other integrations that can supercharge your productivity. For example, Slack to stay updated with real-time notifications in your team channels. X-Ray Test Management for tracking and managing test cases. Power BI, gain advanced insights with rich visualizations for your project data. Once everything is set up, you can exit the configuration. Your GitHub integration is now ready to use. You'll find all your repository details linked within Jira, making project management and tracking a breeze. In Jira, you'll notice the default board setup includes 3 lanes: to do, in progress, and done. However, you can fully customize these lanes to better suit your team's workflow. For example, let's walk through a typical software development workflow and create lanes accordingly. In most companies, the to-do lane contains all the user stories or tasks brought into the current sprint. These are the items the team plans to work on during the sprint. Once a team member starts working on a ticket, they move it to the in-progress lane, indicating the work is actively underway. After development is complete, the developer typically raises a pull request, PR, for their code, which is then reviewed by peer developers. At this stage, the ticket is moved to the review lane. Once the pull request is approved and the code is merged into the main branch, the developer moves the ticket to the in-test lane, signaling that it's ready for QA. The tester then picks up the story, executes the QA tasks, and ensures the acceptance criteria are met. Once testing is complete, the QA assigns the ticket to the product owner, PO, and moves it to the PO review lane. The PO reviews the evidence attached by QA, validates the work, and approves the ticket. Finally, the PO moves the ticket to the done lane and optionally assigns a label for the targeted release. Now, let's quickly create these custom lanes and arrange them in the order of the expected progress: to do, in progress, review, in test, PO review, and done. Now, let's explore the different types of issues in Jira. First, there's the epic, which acts as the parent issue. It represents a large piece of work that's broken down into smaller, manageable tasks or user stories. It's perfect for capturing high-level requirements or initiatives that span multiple sprints or releases. Next, we have user stories, which are more specific tasks derived from an epic. These represent functionality or work from the end user's perspective. A common way to write a user story is, as a customer, I want some functionality, so that, some reason. The goal of a user story is to deliver value and, ideally, to be completed within a single sprint. If a story is too big, it can always be split into smaller parts. Now, let's talk about bugs. A bug indicates something that isn't working as expected. Whether it's a coding error, a design flaw, or an unexpected system behavior. Bugs need to be addressed promptly to maintain the quality and reliability of the software. Finally, there's the subtask, which is a smaller, more focused piece of work tied to a larger issue, like a user story or bug. Subtasks are great for breaking down complex work into manageable steps, making it easier for team members to collaborate and track progress. They're always linked to a parent issue, so they don't exist on their own. In the next video, we'll focus on creating the onboarding flow, where we'll design and develop the welcome screen, onboarding screen, and login screen. These screens are crucial for providing users with a smooth introduction and setting the tone for an engaging experience. After completing the onboarding flow, we'll move on to building key app features. We'll start with the home screen, the central hub where users interact with the app's core functionality. Then, we'll create the Add Record screen for seamless data input, followed by the Analysis screen, which will showcase insightful metrics in a user-friendly way. This session will be full of practical development tips and hands-on guidance, making it perfect for anyone looking to strengthen their app-building skills. Don't miss it. Stay tuned and follow along. Let's start by creating our first issue by clicking on the Create button. In the next window, we'll select the issue type as Epic and then add a summary and description. For our first epic, we'll name it Onboarding and define a clear goal for this epic. For now, we'll leave the other fields as default and click Create to save the epic. Similarly, we can follow this process to create additional epics for the other features. You can navigate to the Filter section, select All Issues, and set the filter type to Epic to view all the epics for your project. Along with the onboarding epic, we've also created another epic called BAU, Business as Usual. This epic is designed to manage stories or tasks that focus on internal management or improvements, rather than features directly visible to the user. The other epics we've created include home screen, add records, search and filter records, analyze records, and app settings. We'll focus on these epics as we progress through the project, tackling each feature step by step to ensure a well-structured development process. Now let's create a few user stories and see how we can link them to an epic. To get started, click on the Create button at the top of the Jira dashboard. This time, for the issue type, select User Story. Let's create a story to set up Spotless in the project. Enter the relevant details, such as the summary and description, and then click on the Create button. Once the story is created, we can repeat this process to create the rest of the user stories quickly. As we add these stories, they'll appear in the backlog, where they can be organized and refined. This backlog is typically reviewed and updated during the backlog refinement meeting, which we discussed earlier, ensuring that all the user stories are ready for prioritization and sprint planning. Finally, don't forget to link each user story to its epic. This helps group related tasks and provides a clear structure, making it easier to track progress and manage work effectively. Let's go ahead and create those user stories now. Once we've created our user stories, the next step is to estimate them. This estimation is usually done during the sprint planning meeting, where the team collaboratively assesses the effort required to complete each story. For estimation, many teams use the Fibonacci sequence, a series of numbers like 1, 2, 3, 5, and so on. These numbers represent the relative effort or complexity of the task. For example, if you assign a 1, it typically means the story is simple and can be completed in a few hours to a day. As the complexity or effort increases, you assign larger numbers like 3, 5, or higher. It's important to remember that these numbers are not precise measurements, but rather a way to estimate effort in relative terms. Different teams may adapt these values or define their own scale to suit their specific workflow. The goal is to agree on an estimate that reflects the complexity and time required for each story, enabling better planning and prioritization for the sprint. Now, let's quickly assign some story points to the user stories we've created. This helps us estimate the effort required for each task and prepare for sprint planning. Once that's done, we're ready to move all the stories into our first sprint. Simply select all the stories in the backlog, right-click, and choose Move to Sprint. This adds them to the current sprint, which is now ready to be started. Next, we'll click on the Start Sprint button. In the window that appears, you can assign a name to the sprint. We'll keep the default name for simplicity. However, we'll adjust the sprint duration to 1 week for this project, though in most companies, sprint durations are typically 2 weeks. Set the start date and define the sprint goal. For this sprint, our goal will be to complete the onboarding flow. Once the sprint starts, you'll see all the user stories appear on the board, which was previously empty. This is where the team will track the progress of each story throughout the sprint. Now, let's see how we can break down our user stories into smaller tasks. This is usually done by the developer working on the story, but it's entirely optional and depends on the team's workflow. To illustrate, let's add a test subtask to one of our user stories. Open the user story you want to break down, and look for the Add Subtask option. Click on it and provide a concise title. You can also add additional details, like specific testing scenarios or requirements, in the description field. Once done, click Create to add the subtask. Subtasks help in organizing work and tracking progress at a more granular level. They are particularly useful for larger stories, as they allow team members to focus on specific aspects of the work while maintaining visibility of the overall progress. Now imagine you're working on a user story during a sprint and encounter a blocker that stops your progress. In this situation, you can flag the story, which changes its color to make it easily recognizable. This allows the product owner, PO, and Scrum Master to quickly identify the issue. The Scrum Master can then take the necessary steps to resolve the blocker, ensuring you can resume your work without delays. You can also view the history of a ticket by checking the Activity tab at the bottom. By selecting History, you can see a detailed log of all the activities and updates related to the ticket. The Timeline tab gives you a clear overview of progress on different epics in your project. It shows a visual timeline of when each epic starts and ends, helping the team track progress and spot any potential delays. This makes it easier to plan, stay on schedule, and see how all the epics fit together in the bigger picture. Right before the Timeline tab, you'll find the Summary tab, which gives you a clear overview of the entire project and the current sprint. It shows key details like how many issues are completed, in progress, or still to be started. You'll also find useful insights like team performance, burn-down charts, and other important stats. It's a great place to quickly check the project's overall progress and the sprint status. You can filter or group user stories based on various criteria such as epics, assignees, and more. This feature makes it easier to organize and focus on specific tasks or categories, helping you and your team stay aligned. For example, you can group all tasks assigned to a particular team member or view all user stories linked to a specific epic, streamlining your workflow and improving clarity. The Sprint Insights section provides a quick overview of how the sprint is progressing. It displays important metrics, such as completed tasks, work in progress, and tasks yet to be started. This gives you a snapshot of the team's progress and highlights areas that may need attention. So let's get started by creating a new project in Android Studio. First, open Android Studio and click on New Project. In the next window, select the empty activity template and click Next. Name the project Cachewise and set the package name to com.coroutine.lab.cachewise. Keep the minimum SDK as API level 24 and select Kotlin DSL for the default build configuration. Click Finish and let the Gradle sync complete. Now we will enable version control. Once the Gradle sync is complete, go to the VCS option at the top and select Enable Version Control. In the next window, choose Git as the version control system and click OK. Now, go to the Git menu, select GitHub, and choose Share on GitHub. In the next pop-up, provide the repository name as Cachewise, keep the remote as origin, and click the Share button. In the next window, deselect the .idea folder to avoid sharing unnecessary files. Add a commit message, CW26 create and add the initial project. Finally, click Push to upload the changes. Once completed, you should see your repository live on GitHub. With that, we've completed our first task. Since this is a technical task that doesn't require testing or review, we can directly move the ticket to the done state. Now, if you check the Sprint Insights tab, you'll notice a slight downward shift in the burndown chart. The sprint burndown chart shows how many points or issues have been completed versus how many remain. The gray horizontal line serves as a guide, indicating where the team should ideally be to finish the sprint on time. This gives you a clear visual of progress and whether the team is on track to complete all tasks by the end of the sprint. With that, we've successfully set up our project and completed our first task. Now let's move to our next story, setting up Spotless. Spotless is a code formatting tool that ensures a consistent code style across large code bases. It automatically applies formatting rules, making it easier to maintain clean and readable code. We'll start by creating a new branch from the main branch named CW9 add Spotless. To set up Spotless, open the libs.versions.toml file. Add the Spotless version 6.25.0 under the versions reference block. In the plugins section, add the Spotless plugin entry. Next, open the app-level build.gradle.kts file. Start by applying the Spotless plugin in the plugins block. Outside the plugin block, configure Spotless to apply to all subprojects in the Gradle build file. Then we configure Spotless to target all Kotlin files in the src directory, while excluding generated files in the build folder. Let's configure Spotless for Kotlin Gradle scripts. Target files with the .kts extension. We also apply kt-lint, a popular Kotlin linter, to enforce style rules in Gradle build files. Finally, we use the after evaluate block to ensure that Spotless formatting is applied automatically after the Kotlin compilation tasks. To validate the Spotless setup, open the terminal and run the command gradle w spotless apply. Next, let's see how we can configure kt-lint to enforce custom style rules in our Android project. We'll configure kt-lint using the editor config override method, which allows us to customize various coding rules. The complete list of rules that can be overridden is available online, and I'll attach the link in the description for your reference. You can tailor them according to your project requirements. Once the configuration is done, we'll push the changes to our branch and raise the pull request. We've used squash and merge instead of the regular merge for our pull request. Squash and merge combines all the commits from a feature branch into a single commit, creating a cleaner Git history. This is suitable only in a small team. In contrast, a regular merge creates a merge commit that combines the feature branch with the main branch while preserving all individual commits. With this, our second goal is also complete. We will now focus on our next task, setting continuous integration using GitHub Actions. The goal of CI is to shorten the feedback loop during development and quickly identify and fix errors. Make sure to pull the latest changes from the main branch to ensure your branch is up to date. Create a new branch and name it CW10. Let's start by adding the first workflow. Right-click on the project name and create a file. Workflows/PR check. The format of this file will be YML. Our objective is to ensure that no developer can accidentally push or merge code into the main branch if the Spotless check fails. To achieve this, let's start by naming our workflow pull request checks. We want to trigger this whenever a pull request targets the main branch. Next, we define permissions for the workflow. The contents. Read permission allows the workflow to read repository contents. While pull requests, write. Let it post comments or update the status of pull requests. Our workflow includes a single job called build, which runs on the Ubuntu latest environment. This job performs all the necessary steps to validate the code in the pull request. The first step uses the checkout action to clone the repository. We then set up JDK17 using the setup Java action. This is essential for building and running Java-based projects. Before running Gradle commands, we grant execute permissions to the Gradle script using the chmod command. Finally, we run the Spotless check to validate that the code adheres to your project's formatting rules. Similarly, we'll create another file in the same directory named delete branch on merge.yml. This workflow will ensure that feature branches are automatically deleted after they are merged, keeping the repository clean and organized. We begin by naming the workflow merge PR. This workflow is triggered when a PR is opened, closed, edited, or reopened. Next, we define a single job named AutoMerge, which runs on the Ubuntu latest environment. The main step in this workflow uses the delete merged action. This action identifies and deletes branches that have been merged into your base branch, excluding the main and production branches from deletion. The GitHub_token is passed as an environment variable, enabling the action to authenticate and interact with the repository securely. Both of our workflows are complete, so let's commit the change and raise the pull request. I'll demonstrate this process once more, but moving forward, we'll skip showing all the PRs at the end of each task to save time. However, You can always check the commit history and pull requests on GitHub to follow along. Each PR will be linked to the ticket number we created earlier, making it easy to track progress. If the spotless check is successful, then we will see the build is passing and we can merge the code to the main branch. You can also check the Actions tab on GitHub, where you'll see the 2 workflows we just created. Let's select our first workflow run from the Actions tab. Here, you'll see details such as who triggered the pull request, the status of the workflow, and the total duration it took to complete the run. Now, let's click on Build. You'll notice all the steps we defined in our workflow being executed in sequence. First, the job setup begins. Then, the checkout step retrieves the code from the repository. Next, the JDK is set up, permissions are granted, and the spotless check is executed. After that, some cleanup steps are performed, and the job is marked as complete. Adaptive icons are Google's way of making app icons look clean, consistent, and polished across all devices. Think of them as your app's chameleon-like feature. They adapt their shape to match the design preferences of the device. Design your adaptive icon at 108 by 108 dp, with pixel dimensions varying based on screen density. But the masking size is only 72 by 72 dp. Keyline shapes are predefined geometric guides that help designers ensure consistent proportions and visual balance. Think of them as design blueprint. The first keyline shape are 2 concentric circles of 52 and 36 dp respectively. The next keyline shape is a square of side 44 dp. And lastly, we have 2 rectangles of given sizes on screen. Built with 2 layers, a foreground, your logo, and a background, solid or gradient. They create depth and support interactive animations on some devices. Plus, Android applies a masking system to ensure all icons maintain a uniform look. Let's see how you can add your own app icon. We will start by creating a new branch and then navigate to the resource folder in your project and create a new image asset. Make sure you have your app icon ready in SVG or PNG format. While PNG works, I highly recommend using an SVG file. It's scalable, lightweight. In the next window, select the folder icon and import your SVG file. Once imported, you'll see all the masked icons generated for different shapes. But we're not done yet. Let's clean it up. Switch to the Background Layer tab and set the background color to match your app's theme. For this example, we'll keep it white for a clean, minimal look. If your logo is spilling out of the mask area, use the scaling option to resize it. Adjust the scale to 49% to bring it safely within the masked area. Once the icon is added, open the IC Launcher Image option to validate how your app icon looks across different sizes and shapes. This step helps ensure it appears clean and well-proportioned on all devices. Quickly commit these changes to your branch to save your work. Well done! You've successfully learned the concepts of adaptive icons and how to add them to your app. There is a lot to come, and so continue watching. If you are liking the video, please hit the like button and subscribe to the channel. We'll now dive into setting up a design system for your app. As always, create a new branch in your version control system to keep your work organized. Right-click in your project and select New Module. In the next window, choose Android Library. Set the module name as Design System. Update the package name as shown on the screen. Once done, click Finish to generate the module. After the module is created, make sure to add it to Git so your changes are tracked. You'll observe that the newly created Design System module has been automatically registered in the settings.gradle.kts file. This ensures the module is properly included in your project structure. Head to your libs.versions.toml file and add the versions for the following. AppCompat, for backward compatibility support. UI tooling, for UI inspection and previewing. Lottie Compose, to include Lottie animations in your Compose components. Also, make sure to add the group name for these dependencies in the library block to organize them properly. Since we created the module as an Android library, it has already been added automatically in the project structure. Navigate to the build.gradle.kts file of the Design System module and configure the Compose plugin. Next, enable Compose build features. In the Dependencies block, include the following. Compose BOM platform. Material 3. Lottie Compose. UI tooling. to support previewing and debugging UI. Next, the goal is to move all theming-related files into the Design System module, keeping everything neat and focused. Take the theme folder from the app module and move it into the Design System module. When you do this, a dialog will pop up asking you to confirm the refactoring. Go ahead and hit Continue. No second thoughts. Why are we doing this? Because we want the design system to focus on just one thing, providing themes and reusable components. No multitasking for our modules. Now, your main activity might throw a tantrum because it can't find the CacheWise theme anymore. Don't panic. This is expected. Let's fix it. Head over to your settings.gradle.kts file and enable Type Safe Project Accessor. This lets you refer to modules like dependencies. Now, in the app modules build.gradle.kts file, add the Design System module as a dependency. Sync your changes, and voila! Problem solved. Main activity is now happy and can find CacheWise theme again. Before we dive into building components, let's take care of a quick setup. Don't worry, it's a simple process. Add a new resource directory. By right-click on your module, select New and then Android Resource Directory. In the pop-up, set the resource type to font. This tells Android Studio that this folder will store all your custom fonts. Now, just drag and drop your font files into this newly created font folder. Pro tip: both .auth and .ttf file formats are supported, so feel free to use whichever works best for your design. Alright, now that we've added fonts, it's time to put them to use and refine our app's typography and color scheme. Let's break it down step by step. We'll start by creating a font family variable in the type.kt file. Add each font along with its corresponding font weight. In Jetpack Compose, typography defines the styling and appearance of text in your app's UI. We'll start by creating a display medium style and specifying font weight for how thick or thin the text looks, font size for the size of the text in SP, line height for the vertical space between lines, letter spacing for the spacing between characters. Next, we'll do the same for other styles like display small, title medium, label small, and label large. You might be wondering, are these sizes just random guesses? Nope, there's a method to the madness. Head over to m3.material.io and check out the typography token section. For example, if we expand the label styles and look at label small, the font weight is medium, so we use font weight medium. The font size is 11 points, which we translate to 11 SP. The line height is 16 points. The letter spacing is 0.5 SP. Following these specs ensures your typography is consistent with Material Design 3 standards. Now let's spice things up by replacing the default colors with your own custom palette. Open the color.kt file. Delete the existing colors, they've served their purpose. Add your own color values, using hex codes that match your app's theme. After updating the colors, you'll notice errors in the themes class because the existing color references no longer exist. Don't sweat it. Just replace the broken references with the new colors you've added, and everything will be back to normal. Now it's time to make your app's layout consistent by creating a dimension file. Here's how we'll do it. In this file, we'll define all the dimensions you'll need for your app. Pro tip: stick to even numbers for dimensions. It just makes layouts look cleaner and more balanced. Next, we'll create a local dimension variable, which is a composition local for a dimension object. Wait, what's a composition local? Think of a composition local as a magic way to share data across your app's UI without needing to pass it down explicitly through every composable. Once you register a value using a composition local provider, it can be accessed anywhere in the app using .current. No more repetitive parameter passing. Let's see an example of using a local theme color. Let's say you've created a local theme color for a gray color. Once it's registered with a composition local provider, you can use it in any composable. Simple, right? It's like having a shared stash of values your app can pull from whenever needed. A few things to keep in mind. 1. Composition locals are scoped, meaning their values are only available within the part of the UI tree where they are provided. 2. If no value is explicitly provided, the default value, defined in your dimension file, will be used. This way, your app always has fallback values, ensuring nothing breaks unexpectedly. Alright, let's keep the momentum going. Next up, we'll create a shapes data class where we'll predefine all the different shapes your app might use. And yes, we'll use composition local for this too. Once the shapes are set up, we'll plug them into your app's theme so they're easily accessible throughout your UI. And just like that, your app will have a consistency. Thanks for sticking around. Let's recap what we've learned so far. We've covered a lot of ground, from creating a module to adding custom fonts. We covered typography the material 3-way. You replace default colors with your own palette. We unlock the magic of composition locals. Before we dive into the code, let's first understand what a span is. Think of it as a way to style certain parts of a text to make them stand out from the rest. You can use spans to highlight words, change colors, add bold text, or even make parts of the text clickable. In Jetpack Compose, we use annotated string to create text with multiple styles, and span styles to style specific ranges of text within an annotated string. Let's make this clearer with an example. We'll start by building an annotated string using build annotated string. Within this, we use the withStyle function to style parts of the text. For instance, we can highlight a word by making it red and bold. You can see some common use case of spans on the screen. Let's move to building our span framework. Let's start by creating a sealed class called spanType. A sealed class lets us define a restricted hierarchy of types, and all its subclasses are known at compile time. If you're unsure what a sealed class is, let us know in the comments. Maybe we'll make a quick video on it. We've defined 3 types of spans. 1. URL span, for links. 2. Click span, for clickable text. 3. Heading span, for styling headings. Next, we'll create a helper function that takes normal text and a list of span type objects and builds an annotated string based on the spans. Start by defining a current index equals 0. For each span, find its index in the full text. Check if the span exists in the text. For a URL span, use withStyle to add a hyperlink. For a click span, use a clickable annotation. Next, let's do optimization using scope functions. We can clean up this function further by using scope functions like with or apply to reduce redundancy. For example, instead of calling withStyle multiple times inside the when block, we can move it outside the when block and just define the style conditionally. Here's the final version with optimizations. Alright, let's take your app's text styling to the next level. In this section, we'll create custom text types, build reusable text components, and even set up our own preview templates for better visualization. Let's break it down step by step. First, we'll define an enum class to list all the different types of text styles we want to support in the app, like headings, body text, captions. This keeps things organized. We'll create helper functions. getColors extension function, a composable function that matches each text type to the appropriate color from the material theme. getStyles extension function, another function that returns the typography for each text type, pulling from the typography system we set up earlier. Now it's time to build the main attraction, a custom composable text component called CWText. It will take 3 parameters: the text to display, the text type, and text alignment. While it's common to include a modifier parameter in composables for flexibility, we'll keep this one simple and easy to use. For the style and color, we'll use the helper functions we just created to automatically apply the correct settings. Next, we'll create a variation of CWText that supports annotated strings instead of regular text. This allows you to include spans, links, or other rich text styles. We'll call CWText with different parameters to see how each text type looks. Visualizing your components is key. So let's add previews for our CWText composables. Use the app preview annotation to see how your text looks in real time, without needing to run the app. Wrap your text components in a column to display them stacked vertically in the preview. After building and refreshing, you'll be able to see the preview instantly. While Jetpack Compose provides powerful preview templates like preview screen sizes and font scales, sometimes you need something tailored to your needs. We'll create a custom annotation class called CW Preview. This combines font scaling, dark light themes, and device settings into one template. We'll add annotations like at retention, binary, and at target to scope this to functions or other annotation classes. By replacing the regular at preview annotation with at CW Preview, you'll have a cleaner and more personalized preview setup. Wait, Something's off. Even though we set the UI mode as night in our preview, it's still showing the light theme. Here's the fix. We'll create a preview surface composable to wrap our previews. The surface composable automatically applies the correct content color for all its child composables based on the theme. Once we replace the column with preview surface, voila, you'll see both dark theme and light theme previews side by side. We could just use Jetpack Compose built-in text composable directly, but when you're working in a big team or organization, it's important to create predefined, reusable APIs. This way, your components are simple, consistent, and easy for everyone on the team. So, let's do the same for buttons, just like we did for text. We'll start by creating an enum class called buttonType to define the 3 types of buttons our app will support. Filled tonal button for a button with a primary color background. Secondary button, a simple, text-only button with no background. Elevated button, for a button with a subtle elevation for depth. Just like we did for text, we'll create some helper functions to handle styles, colors, and other button properties based on the button type. An extension function that returns the correct text style for each button type. Another extension function to set the elevation for each button type. GetButtonColor function determines the button's background. For buttons, width is often a question of consistency. If a button needs to take up the full width of the screen, we'll use FillMax width. Otherwise, we'll give it a fixed width of 180 dp. Regardless of the width, the height will always remain 56 dp. Now it's time to bring everything together. We'll create a custom composable CW button. We use parameters. Text for the button. An optional icon. The button type to determine styles. A lambda on-click function for handling user actions. Inside the button, we'll use a row with centered horizontal alignment to display the icon, if available, alongside the text. For the text, we'll reuse the CW text composable we built earlier to keep things consistent. To add some variety, we'll create a specialized Google button composable. This button will take 2 lambda functions, on success and on failure, for handling different outcomes. We'll implement the actual functionality for this in a future video, but for now, the basic structure is ready. Finally, let's see if everything works as expected. We'll create a button preview composable to display all the different button types. Next, let's bring your app to life with some Lottie animations. These are great for adding those fun, engaging animations. We'll create a Lottie composable that can load Lottie animation files directly from a URL. This makes it super flexible and reusable, as you can easily swap out animations without touching your code. We use Remember Lottie Composition to create and cache the Lottie composition object. This ensures the animation is loaded and remembered efficiently without reloading every time the composable recomposes. To play the animation, we use Animate Lottie Composition as state. This manages the animation's playback and state seamlessly. Let's create a smooth and visually appealing pager for your onboarding screen. It's a must-have to guide users through those initial steps with style. We'll start by creating a composable that includes the essentials. Page count, how many pages your onboarding flow will have. Pager state, this will control the pager and let us observe properties like the current page. Composable lambda, a flexible way to pass the content of each page dynamically. We'll use a column with its horizontal alignment set to center. Inside this column, we'll add a horizontal pager, which will use the pager state to control and monitor paging. Take up the remaining space with modifier.weight. Indicators give users a clear sense of where they are in the onboarding flow, so let's create them. We'll build a row of indicators that 1. Track the current page. Use the current page index to highlight the active dot. 2. Know the total page count, so we can draw the correct number of indicators. Based on the total page count, we will create the required number of indicators using the repeat function. Style each indicator's shape, color, and size based on whether it's the current page or not. To draw the indicator itself, we'll use a box and clip it to the desired shape. Let's quickly preview our view pager and see it in action on a device. Once that's done, we'll move on to building an error banner, a red banner that pops up to show error messages whenever something goes wrong. It's a simple yet effective way to communicate issues to users, and it will automatically disappear after a given time. Let's dive in. We will create screen contain. This composable will accept a Boolean to determine whether the banner is visible, a string for the error message, a lambda composable to wrap the actual screen. We'll use remember to save the state of the Boolean show error. This ensures the state is preserved across recompositions. To manage the visibility of the banner, we'll use a launched effect. A launched effect is a composable that runs a block of code whenever a key parameter changes. It cancels the previous coroutine if it's still running when the key changes. It's lifecycle aware, which means the coroutine is cancelled automatically when the composable leaves the composition, preventing memory leaks. Let's see a code examples. If the key is unit, the block only runs once because unit doesn't change. If the key is dynamic, example, user ID, the block will rerun every time the key changes. We'll use the show error Boolean as the key. This means the launched effect will trigger every time show error changes, ensuring the banner appears when needed and disappears after the timer expires. For the error text, we'll simply use a text composable to display the message. Yes, we should have used the reusable CW text composable here, but I'll update this in a future commit. No one's perfect, right? To make the banner appear and disappear smoothly, we'll use animated visibility. Define custom enter and exit animations.
So what's the deal with UI text? It's a sealed interface with 3 types of text it can represent. 1, string resource, ideal for Android string resources. 2, simple string for plain simple text, the classic kind. 3, empty string, a singleton representing, well, nothing. Genius, right? And here comes the magic. The getString function decides what to show based on the UI text type. An empty string for empty string, plain text for simple string, or a localized resource string using context.getString for string resource. Step 2, configuring our libs.version.toml file. We'll add the coin bill of materials to manage dependencies like a pro. And guess what? We're also adding Android X splash screen for smoother transitions and compose navigation for type-safe navigation. No more errors in moving between screens. The coin bomb entry sets up a bill of materials bomb to manage versions for all coin modules, ensuring they stay consistent. Then you have other coin modules like Coin Core, which is the core library, Coin Android for Android-specific features, and Coin Compose, which integrates Coin with Jetpack Compose. Coin Compose navigation and Coin View Model are there to handle navigation and view model efficiently. Oh, and Kotlin serialization plugin will handle all our Compose navigation needs. Next up, the onboarding module. It's time to get organized and efficient. Till the last video, we created an app and design system module. Now it's time to create our onboarding data, domain, and presentation module. Let's make this even more awesome. Here's what we're doing. 1, create a library module named Feature Onboarding Presentation. Done. 2, add an onboarding domain module because structured code equals happy developers. 3, add an onboarding data module to maintain that Uncle Bob clean coding architecture. And guess what? Teams can work simultaneously without stepping on each other's toes. Additionally, this approach accelerates the development process. Isolated modules allow for more focused and efficient testing, making everything smoother and faster. Wait for the Gradle to complete. Patience pays off, doesn't it? Once everything is synced, open your onboarding presentation build.gradle.kts file. We'll start by applying the Compose plugin since we're going to write our UI in this module. Exciting, right? Next, we'll enable the Compose build feature. After that, we'll add the design system project dependency. On top of this, we'll include the Coin bill of materials, along with dependencies for Android and Compose. Finally, we'll add the strings needed for the welcome screen. To do this, create the Android resource directory and add strings.xml under the values directory. We already covered this in the last video, so you're a pro now, aren't you? Now, let's dive into UI building. Ready? First, we create the welcome screen composable, which takes the onNextScreen Lambda function as a parameter. We'll use this later in our navigation module to navigate to another screen. Now we've created 2 composables. Why 2? That's because later we'll leverage the powerful concept of state hoisting. State hoisting is another important concept here. It helps us manage and share state in a composable app by lifting state at a higher level for better control. Let's break down the UI to fully understand what we're building in the welcome composable. Inside, a column, which neatly arranges its child elements vertically, stacking them one after another from top to bottom. Inside the column, we'll add a row that arranges its child elements horizontally. Within this row, we'll place an image and some text, a button to navigate ahead. Simple. Okay, let's move to the coding part. It's time to bring our design to life. We'll begin with a column, our go-to layout for stacking elements vertically. To make it fit perfectly, we'll apply the fill-max size modifier and add padding on all sides based on the design. Padding creates that much-needed breathing room for composables. Inside the column, we'll include a row. This will span the full width and adjust its height dynamically based on its child composables. It's flexible and just what we need. Next up, we'll insert an image with a fixed size of a 128 dp. Using local dimensions and current, as we covered in the last video, will ensure everything scales beautifully. Finally, let's add 3 text elements to the column. We'll use our predefined text types: title, display, small gradient, and label small, to maintain consistency and add a professional touch. These little details make all the difference. The spacer is a composable function designed to create empty space, adding balance and structure to your layout. Finally, we'll add the CW button, and in its on-click, we'll invoke the Lambda function on next screen to seamlessly navigate to the next screen. Horizontal arrangement in Jetpack Compose is a property used to control the horizontal positioning and spacing of child elements within container components like row. It allows you to specify exactly how the children should be arranged along the horizontal axis. Congratulations on creating your welcome screen. Here's a quick preview of how it will look. Amazing, right? Next, head over to your strings.xml file again and add some of the strings as shown on screen for our next intro screen. We've created some Lottie animations using Lottie Lab and exported them as JSON URLs. This way, we don't have to include them locally in the raw folder, significantly reducing the app size. These animations are so well optimized that their size is hardly over 10 kilobytes, making them quick and efficient to load over the internet. Let's take a quick look at how we're going to design our intro screen. Most of the components were already created in the last video, so implementing this should be quite straightforward, right? We'll create the introduction screen composable, which will also take the same Lambda function. You can take a look at the quick hierarchy of the composable that we're about to implement inside the onboarding composable. Let's get to it. We'll start by using a column with appropriate padding and horizontal alignment set to center horizontally. This ensures all children of the column composable are neatly centered, creating a balanced and polished layout. We've also utilized Remember Coroutine Scope, which provides a coroutine scope tied to the life cycle of the composable where it's called. Any ongoing coroutines launched within this scope are automatically canceled when the composable is removed from the composition, preventing memory leaks. Additionally, we've included conditional button text, which dynamically changes based on the current page count. This adds a layer of interactivity and personalization to the experience. This code creates a UI layout featuring a pager for swipeable content and 2 buttons. 1, the pager with indicator displays a series of pages controlled by pager state. 2, the first button, CW button, advances to the next page or triggers on next screen when the last page is reached. 3, the second button, labeled skip, also invokes on next screen, allowing users to bypass the pager entirely. Inside the pager, we'll use a column to display. 1, an animated Lottie file to add a touch of modern elegance. 2, a headline with custom styling that emphasizes the first word for added impact. 3, a descriptive label to tie everything together beautifully. The Lottie animation is dynamically loaded from a resource array, while the headline styling ensures it stands out. Here's a quick preview of how the screen will look when we run the application in both dark and light themes. It's time to build our sign-in screen using a similar approach. This screen is simple yet essential, featuring 2 text elements, 2 buttons, and a spacer for proper layout spacing. The sign-in screen takes 2 parameters. 1, on next screen, a callback for navigating to the next screen. 2, on error, handles errors using a Boolean flag and a UI text message. We'll implement the on-error functionality in the next video when we introduce Google Sign-In. For now, let's focus on building the layout. This code creates a sign-in screen layout font using a column to organize various UI elements. At the top, a styled CWG text displays the title with a highlighted span, making the heading visually appealing and professional. A Google button lets users sign in with Google, handling success or failure through callbacks. A guest sign-in button offers an alternative option, triggering navigation to the next screen. At the bottom, a terms and conditions text, styled using CW text, includes clickable URLs with bold and secondary color spans. Once we design our terms and conditions webpage, we'll replace the placeholder URL with the actual link. Here's a quick preview of how our sign-in screen will appear. Simple, functional, and visually clean. Congratulations on making it this far. You've mastered key concepts like column, row, arrangement, and alignment. You've also learned about spacer and explored the power of remember coroutine scope. Amazing progress. Feel free to take a break if you need it because the journey doesn't end here. There are plenty more exciting concepts waiting for you in the next part of this video. Let's keep the momentum going. We will start creating a new module now. Just like we created the onboarding data, domain, and presentation module inside the feature, we will create a similar module for our main module. This will also include data, domain, and presentation layers for better organization and maintainability. Open the presentation build.gradle.kts file. Start by applying the necessary plugins, including Kotlin Compose and Kotlin Serialization. In the dependencies block, reference other project modules like onboarding presentation, design system, and main domain. Additionally, include Compose-related libraries such as Material3, Lifecycle Components, Navigation, and Splash Screens. The coin dependencies are added via a BOM to manage dependency injection efficiently. Next, define two sealed interfaces, graphs and destinations, to organize and represent navigation in an Android app in a structured, type-safe way. Graphs categorizes broader app sections. Onboarding represents the onboarding flow. Dashboard represents the main dashboard flow after onboarding. Destinations breaks down individual screens. Both interfaces are annotated with @serializable, making them compatible with Kotlin serialization for tasks like saving or transferring navigation states. Next, define a generic extension function for NavGraph Builder to simplify adding a composable screen to the navigation graph. Enter transition defines how the screen appears with a smooth sliding animation from the start. Pop exit transition defines how the screen exits with a sliding animation to the end. This encapsulates navigation transitions and simplifies reusing animations across multiple screens. Now, let's dive into a few important Kotlin keywords to understand their role. 1. Inline instructs the compiler to replace a function call with the function's actual code at the call site, improving performance and reducing memory overhead. 2. Reified, used with inline functions to preserve generic type information at runtime. With reified T, the function can work with a specific destinations type while ensuring compile time safety. 3. Noinline prevents a specific Lambda parameter from being inlined in inline functions. While inline functions inline both the function and past Lambda functions by default, noinline provides an exception to this behavior. Next, either delete the main activity in the app module or refactor it into the main presentation module. If you're refactoring, delete all the content and add the following code. Install splash screen ensures the splash screen displays seamlessly as the app launches. Enable edge-to-edge customizes the app's layout to take full advantage of the screen, such as removing system bars or making UI elements adapt to edge-to-edge designs. Now, let's create our CW app composable. This composable sets up the core structure of the app by combining navigation, theming, and error handling. Use Remember Nav Controller to initialize a nav controller, which handles navigation within the app. Inside launched effect, when show error message becomes true, it triggers a delay of 3000 milliseconds before hiding the error message automatically. This ensures errors are displayed briefly without interrupting the user experience. NavHost sets up the navigation graph, starting with the onboarding screen. Next, implement the Navigate to Onboarding function. This function defines the onboarding navigation flow using NavGraph Builder. It Starts at destinations.welcome, navigates through introduction, ends at sign in, with each screen implemented as a CW composable, passes an on-error callback to handle errors on the sign in screen. Open the app build.gradle file and update the dependencies block to include the main presentation project. Also, ensure the path to the main activity is updated in the manifest file of the app module. At this point, if you run the app, you should see all the screens working with proper navigation. If learning about inline, no-inline, and reified keywords in Kotlin, as well as creating a nested navigation setup isn't enough, stay tuned. Let's keep moving and create another module. Here's the module structure we'll have once it's created. This module will be a Java or Kotlin library, unlike the Android library modules we created earlier. Once the module is set up, click Finish and wait for the Gradle sync to complete. After the sync is complete, delete the myclass.kt file that was generated by default. Next, head over to the libs.version.toml file. We need to include additional dependencies. Add versions for libraries like ArrowCore, Datastore, Protobuf, and Compose Runtime, mapping them to reusable keys for consistency and maintainability. The Protobuf Gradle plugin is essential for integrating protocol buffers, Protobuf, into your project. Protobuf, developed by Google, is a powerful serialization library that helps define structured data formats and generates efficient code for data exchange. For now, we'll only add the ArrowCore dependencies to our common model project. The other dependencies will be utilized later in the upcoming steps. Next, we'll create some config files, which we'll use later in the project. Start by creating the auth_config enum class to define possible authentication states for a user. Enum classes are incredibly useful for representing a fixed set of constants. In this case, the user can be in one of three states: 1, unauthenticated; 2, authenticated; 3, guest mode. Similarly, we'll create the onboarding config enum class. This class defines the user's onboarding status. For example, not started. The user is interacting with the app for the first time. In progress. The user has progressed past the welcome screen but hasn't completed the sign-up process. Completed. The user has successfully signed in, marking the onboarding process as finished. Next, let's set up the theme config enum class, which allows the user to choose how the app looks. There are three options. System matches the app's theme with the device's system settings. Light provides a bright, clean interface. Dark offers a darker, visually relaxing experience. Lastly, we'll create the user class, which represents the user within the app. It holds name, the user's name. Profile picture URL ensures the user's profile information is displayed correctly and consistently. With these configurations and classes, we're laying a solid foundation for the project's structure and functionality. Now let's move forward to step 7, which is to create the Datastore module. From our current structure, we'll add another Android library and name it Storage Datastore. This will act as the backbone for managing user preferences. Later in the series, we'll also use RoomDB, for which we'll create a storage database module. This ensures a clean separation of responsibilities for different storage mechanisms. Open the datastore/build.gradle file and add the Protobuf plugin. This configuration generates lightweight Kotlin and Java classes from .proto files, making it easier to work with structured data. It uses the Protobuf compiler, Prodoc, and optimizes the generated code for better performance and smaller size with the light option. In the dependencies block include Datastore for local storage, Coin for dependency injection, Protobuf for lightweight data serialization, shared models from the project. Next, create the Proto directory just below the Java directory. This is where we'll define our Protobuf schema files. 1, auth status enum defines your authentication state, not authenticated, authenticated, guest. 2, onboarding status enum tracks the user's progress in the app's onboarding process, not started, user is new. In progress, onboarding is ongoing. Completed, onboarding is finished. 3, theme enum manages the app's appearance preferences with options like system, light, and dark. 4, user preferences message stores the user's personalized settings, including theme preference, theme, onboarding progress, onboarding status, authentication status, auth status, default currency, notification preferences, Next, in your terminal, run the command bashed/Gradle storage datastore build. This builds the Gradle module located in the storage datastore directory, compiles the code, and processes the protobuf file. The user preference serializer handles saving and loading preferences like theme, onboarding progress, or notifications into a protobuf-based data store. This class implements serializer from Android's data store library and provides two key methods. Read from reads and deserializes preferences from an input stream using protobuf's parse from method. Write to serializes preferences and writes them to an output stream with write to. The with context function in Kotlin coroutines allows you to execute code in a specific coroutine context, especially useful for handling I/O-bound operations, enabling other coroutines to use the thread while waiting for I/O completion. We'll use dispatchers.io, which provides a shared thread pool optimized for I/O tasks, ensuring blocking operations don't interfere with the main thread. The user data source class interacts with a protobuf-based data store to manage user preferences. It provides the user data method, which returns a flow. This allows the app to observe real-time changes to user preferences, such as theme settings or authentication status, ensuring the UI stays up to date with the latest data. Here are key methods in user data source. 1. Set theme updates the user's theme preference in the data store. 2. Set auth type updates the user's authentication status, mapping auth config to the corresponding auth status value. 3. Set onboarding status updates onboarding progress, mapping onboarding config to its corresponding onboarding status, and safely persists the updated state using datastore.updateData. 4. Set default currency updates the user's preferred currency in the data store. 5. Set is notification enabled updates notification preferences to remember whether notifications are enabled or disabled. The preference module defines a CoinMine module to manage dependencies for user preferences. It 1. Registers a singleton instance of the user preference serializer responsible for reading and writing protobuf-based user preferences. 2. Configures a data store instance using the user preference serializer. This stores data in a file named userpreferences.pb within the app's internal storage. 3. Registers a singleton instance of the user data source, which provides methods to access and update user preferences, injecting the configured data store as its dependency. We have most of the pieces we need to save and retrieve our preferences, so let's move on to the main domain model now. Start by updating the domain build.gradle.kts file. Make sure to include the common model project as a dependency. This ensures seamless integration between modules and avoids duplication. Next, create the userpref data class. This class will hold all your app's user preferences, such as theme settings, onboarding status, authentication state, default currency, notification preferences. Now let's define the user preference repository interface, which serves as the contract for retrieving user preferences. It includes a method getUserPreference that returns a flow. This allows your app to observe real-time updates to user preferences effortlessly. With this setup, we're laying the foundation for a highly dynamic and responsive application. Now let's move on to the main data module. Start by updating the build.gradle file as shown on the screen. Include both the data store module and the domain module. Next, let's focus on the user preference repo class. This class implements the user preference repository interface and retrieves user preferences as a flow. Here's what it does. Fetches raw data from user data source, maps protobuf-generated enums to app-specific configurations, emits a well-structured userpref object ready to be consumed by the app. Now let's dive into two important concepts. 1. Flow in Kotlin. A flow is a cold, asynchronous data stream that emits values sequentially over time. It's the perfect choice for scenarios like observing real-time data changes, such as user preferences or database updates. The best part, it only runs when it's collected, ensuring efficient resource usage. 2. Emit function. The emit function is used within a flow builder to push values downstream to the collector. It's essentially how you make data available to whoever is collecting it. Let's keep going. Next, we wire up dependencies for your app's main data layer. Use single-of to create a singleton instance of user preference repo impl. This ensures only one instance of user preference repo impl exists throughout the app's lifecycle. The bind function ensures that user preference repo impl is available wherever user preference repository is required. dependency injection made simple and effective. The next step is to update the onboarding domain module. This will be very similar to what we just did with only minor changes. Start by updating the build.gradle file as shown on the screen. Now let's focus on the user preference repository interface. It defines methods for saving user preferences. Save user auth updates the user's authentication type. Save user onboarding status records the user's progress in the onboarding process. With these methods in place, the repository becomes a central hub for managing user preferences efficiently and cleanly. Let's keep pushing forward. Moving on to the onboarding data module now. Start by updating the Gradle file as shown on the screen. This step ensures that all required dependencies are properly configured and ready to support the onboarding data layer. Next, let's focus on the user preference repository impl. This class implements the user preference repository interface by delegating tasks to the user data source. Specifically, it saves the user's authentication type using setAuthType, updates the onboarding status using setOnboardingStatus. This approach ensures that preferences are stored efficiently in the data store, maintaining both reliability and performance. Lastly, define the onboarding data module dependency. This step ties everything together, making the onboarding module robust and fully functional. Head over to the onboarding presentation module now. First, let's talk about the event sealed interface. This interface is used to represent app-specific events, such as onboarding in progress or onboarding completed. By leveraging sealed interfaces, we ensure compile time checks for all possible events, making the app's event handling not only predictable, but also easier to manage. Next, let's focus on the onboarding view model. This view model handles onboarding-related logic and updates user preferences based on events. Here's how it works. The event function listens for specific event types, such as onboarding in progress or onboarding completed. It uses viewModelScope.launch to call the preference repository asynchronously. The onboarding status is updated in the data store by saving onboardingconfig.inProgress or onboardingconfig.completed. Lastly, we define the onboarding module, a coin module that provides the onboarding view model. It injects the required user preference repository dependency using get. This ensures the view model is fully equipped to manage onboarding logic efficiently. Earlier, we created the welcome screen, and now it's time to update it. The welcome screen now includes a view model parameter and passes the view model event function as a dispatch parameter to the welcome composable. This enables button clicks to trigger events, ensuring that the view model efficiently handles state updates. Next, we'll update the introduction screen, which also now includes a view model parameter. Here's the exciting part. When the next or skip button is clicked, they call dispatch event.onboardingCompleted to mark the onboarding process as complete while seamlessly navigating to the next screen. Moving on to step 13, which is to update the main presentation module. We'll start with the UI state sealed interface, which represents the UI's state. It has two key states. Loading indicates a loading state. Success holds the loaded user pref data, ensuring the UI reflects the latest user preferences dynamically and efficiently. Next, let's look at the main view model. This view model manages the app's main UI state using a state flow. It observes user preferences from the user preference repository, maps them to UI state.success, starts with an initial loading state, and uses state_in to ensure the UI always reflects the latest state while sharing data efficiently within the view model scope. The presentation module includes the onboarding module and provides the main view model, injecting the user preference repository dependency using get. This ensures a smooth connection between layers for data handling and UI updates. Now let's move to main activity. We'll make some changes to observe the UI state effectively. The updated main activity integrates the main view model using Coin's view model delegate and observes the UI state using lifecycle scope. The splash screen remains visible during the UI state.loading phase. The main content is displayed only after UI state.success is received. Let's also cover some important concepts. Mutable state of. This creates a state object that triggers UI recomposition whenever its value changes. It's perfect for managing reactive state in Jetpack Compose. Lifecycle.repeatOnLifecycle method. This method ensures efficient resource usage by collecting flows only when the lifecycle is in the started state. It automatically cleans up resources when the lifecycle stops, making it both robust and efficient. Similarly, let's update the CW app. Here's what we need to change. The updated CW app now takes UIState.success as a parameter too. Dynamically configure the app's theme using isDarkTheme UIState. Determine the start destination based on the user's auth type. It also adjusts the onboarding navigation by passing the user's onboarding status, ensuring the UI adapts perfectly to the user's preferences and progress. Key functions. 1. Get destination sets the start screen based on authentication. Authenticated users are directed to the dashboard, while others are guided through onboarding. 2. isDarkTheme dynamically configures the app's theme based on the user's preference or system settings. Since we updated our navigate to onboarding, it's time to update this as well. The newly updated navigate to onboarding now takes an onboarding config parameter to dynamically set the onboarding flow's start destination. It uses get destination to determine the appropriate starting point based on the user's onboarding progress. Additionally, we've introduced a brand new function, navigate to dashboard. This function defines the navigation flow for the dashboard, starting precisely at destinations.home. And now the final step, updating the app module. Let's ensure that every change integrates smoothly. We will start by updating the app module Gradle file. The updated dependencies now include additional modules, main.data and onboarding.data, along with libraries like Coin for dependency injection and Compose runtime. The app module serves as the single entry point for all the modules required by the app. It includes main data module for managing main data dependencies, onboarding data module for onboarding specific dependencies, presentation module for view models and UI-related dependencies. Now let's create the app class and extend application. Here's the plan. We initialize Coin in the onCreate method to set up dependency injection for the entire app. This ensures Coin is ready to provide all the modules like app module throughout the app's lifecycle. Dependency management just got a whole lot smoother. When using Coin, we'll also utilize Android context. This provides the application context to Coin, allowing it to resolve dependencies that require Android-specific components like context. Finally, we'll update the Android manifest.xml to reflect these changes. Don't forget, if required, do a clean build and run the app to ensure everything is working perfectly. Let's get this done and watch everything come together beautifully. We'll create a project in Firebase and enable Google Sign-In and Anonymous Sign-In methods. Once the project is ready, we'll link it to Android Studio. At this stage, the Google JSON configuration file will be generated and added to our app. We'll quickly set up the dependencies needed to integrate Firebase services. Modify our code to call Firebase auth services for managing user sign-in. Finally, we'll ensure everything works as expected by testing the authentication flow. So let's roll up our sleeves and start coding. Head over to console.firebase.google.com and click Get Started to create your Firebase project. In the next window, you'll need to give your project a name. Let's call it Cachewise. Accept the terms of usage and click Continue to proceed. Next, enable Google Analytics for this project and click Continue. You'll then be prompted to provide your location and accept some additional terms and conditions. Once done, click Create a Project. It might take a moment, but once the project is ready, navigate to the Authentication section. Here, you'll be asked to add the sign-in methods you want to enable in your app. We'll start with Google and later enable anonymous sign-in. When selecting Google, toggle the switch to enable it. Provide a support email to proceed. Expand the Web SDK configuration section and copy the web client ID. Keep this ID safe, as we'll need it later in this tutorial. Now let's add a new Android library module. From the last video, we already have some modules in place. This time we'll add a new module named Network Firebase-Auth. Once the sync is complete, go to Tools and select Firebase. This will open the Firebase Assistant window. While there are several options available, such as integrating analytics, real-time database, and Cloud Firestore, we'll only focus on authentication for now. In the next window, click on Connect to Firebase. This will take you to your browser where Android Studio will attempt to establish a connection with Firebase. Once the connection is successful, close the browser window and return to Android Studio. You'll notice that the Google-services.json file has been added to your app module automatically. We won't proceed with the remaining steps in the Firebase Assistant since we're working in a multi-module project and not a single repository. Instead, we'll manually add the required dependencies to our targeted module, ensuring a clean and efficient setup. Let's keep going. Sign in with Google is a 4-step process that ensures seamless and secure authentication for your app. First, the user taps a Sign in with Google button in your app. Your app leverages the Credential Manager to present sign-in options to the user. This is achieved by creating a Get Google ID option and a Get Credential request. The user then selects a Google account from the available options. Upon successful authentication, your app receives a Google ID token credential containing the user's Google ID token. This token is essential for verifying the user's identity. Your app then sends this Google ID token to Firebase Authentication. Firebase acts as the trusted intermediary, handling the validation process. Lastly, Firebase verifies the token's validity. If successful, it creates or signs in the user within your Firebase project. Firebase then responds with an acknowledgement in the form of a task completion specific to Android. Let's start making some changes to our code now. Update the libs.version.toml file. The version section defines version references for libraries such as Firebase Auth, Google ID, and credentials. The libraries section maps these versions to the respective library coordinates. The plugin section configures the Google Services plugin, which is essential for integrating Firebase into the project. Next, update the project build.gradle.kts file. Add the Google Services Gradle plugin in the plugin section as a build dependency. The apply false directive ensures that the plugin is not automatically applied to all subprojects, giving you control over its application. Because let's face it, no one likes plugins running wild on their own, right? Next, update the app module build.gradle file. Add the Google Services plugin to the app module. This plugin is required to parse the Google Services.json file, which contains essential configuration details for Firebase services, including authentication. Up next, let's update the design system build.gradle file. Include dependencies for Android X credentials and Google ID. Now, update the Firebase auth module build.gradle file. In the dependencies block, integrate Firebase authentication and Google Identity for managing user authentication. Add coin for dependency injection and include the common module for shared logic. Lastly, update the onboarding feature data module build.gradle file. Include the Firebase auth module we just created. This ensures the onboarding feature has access to Firebase authentication for seamless user sign-ins. With these updates, we've completed setting up the build.gradle files. Everything is now configured to support Google sign-in and Firebase authentication. Let's go. Next, let's create the sign-in error class in the common module. The sign-in error is a sealed interface with 3 possible error types. Invalid credentials indicates that the provided credentials are incorrect. Invalid user represents a scenario where the user does not exist or is invalid. Unknown error captures any unforeseen or unspecified errors. Using a sealed interface ensures that all possible error types are known at compile time. This allows for exhaustive when expressions, preventing the addition of new error types outside the defined scope. Next, let's add some strings to the onboarding presentation module's strings.xml file. Remember when I asked you to save the web client ID? Now it's time to use it. Create a strings.xml file in the design system module and add the client ID there for easy access. In the second video of this series, we created the Google button. Now we'll continue to update it. The onSuccess parameter now accepts a credential object instead of a unit function, making it more specific and useful. The credential manager is created using the current context. This initializes and configures the credential manager to handle authentication or authorization operations related to user credentials efficiently. Inside the CDA button's onClick lambda, a Get Google ID option is built with specific settings to define how Google credentials will be handled. A Get Credential request is created using the Google ID option to initiate the credential retrieval process. A coroutine is launched within the onClick lambda to handle the asynchronous credential retrieval process seamlessly. The credential is requested using manager.getCredential, and the result is passed to the onSuccess callback if the operation is successful. If an exception occurs during the process, the error message is passed to the onFailure callback. Next, let's create the authentication helper class inside the Firebase auth module. The authentication helper class provides a convenient way to access the current user's information from Firebase authentication. The getCurrentUser method retrieves the logged in user's display name and profile picture URL, wrapping them in a custom user object. If no user is logged in, it returns null. The sign-in anonymous function in Authentication Helper uses Firebase's anonymous authentication to sign in users without credentials. If the sign-in is successful, it returns authconfig.authenticated. If it fails, it returns signinerror.unknown_error. The result is wrapped in an either type. Let's learn about either in Arrow Kotlin. Either is a functional data type used for error handling and represents computations with two possible outcomes. Either.left represents errors or failure cases. Either.right represents successful outcomes or valid results. This approach makes handling both success and failure scenarios much cleaner and type-safe. The sign-in with Google function uses a Google ID token to authenticate with Firebase. If the authentication is successful, it returns authconfig.authenticated. For failure scenarios, it returns specific sign-in error types, such as invalid credentials or unknown error. Run catching is a higher-order function that encapsulates a block of code that might throw an exception. It returns result success with the value, or result.failure with the exception. Get or else provides a clean, functional way to handle both success and failure cases. If the code executes successfully, it retrieves the result. If an exception occurs, it falls back to a default value or logic, avoiding traditional try-catch blocks. This coin module defines dependencies for Firebase authentication. It provides a single instance of Firebase auth and an authentication helper, which utilizes the Firebase auth instance. The auth repository interface establishes the contract for authentication operations. It offers a property to access the current user and two suspend functions for signing in, one using a token and another for anonymous sign-in. Both sign-in methods return an either type, representing either a successful auth config or a sign-in error, ensuring clear and consistent error handling. The auth repository impl class acts as a clean wrapper for the authentication helper, providing a streamlined interface for authentication tasks. It includes methods for retrieving the current user, signing in with Google, and anonymous sign-in. By delegating these operations to the helper, it abstracts away the implementation details, improving the modularity and readability of the authentication logic. The onboarding data module defines dependencies for user preferences and authentication. It creates singleton instances of auth repository impl, binding them to their respective interfaces, and incorporates the Firebase module for additional Firebase-related dependencies. We created the event sealed class in the last video, and now it's time to update it. The event interface has been expanded to include new events for Google Sign-In and Anonymous Sign-In, allowing for more granular and specific user actions. Furthermore, a new effects interface has been introduced to handle navigation and error display. This separates UI effects from events, creating a clear distinction between state management and UI interactions. Moving to the onboarding view model, we had been handling two events in the last video. In this update, we've implemented several key changes to enhance its functionality and improve error handling. A new dependency, the auth repository, has been added, signifying that the onboarding process now includes authentication-related tasks. We've introduced a mutable shared flow of effects, which is exposed as a read-only shared flow. This addition plays a crucial role in handling side effects reactively, allowing one-time events or effects to be emitted and observed by the UI. This approach improves the responsiveness and clarity of user interactions. The new getErrorMessage function maps sign-in error types to user-friendly UI text objects. Let's manage the sign-in with Google event, which we recently updated. The function uses Google ID token credential to process the Google ID token, leveraging the Credential Manager API for secure authentication. The auth repository.signin method is called with the ID token, implementing a robust server-side verification process. Upon successful sign-in, the user's authentication config is saved using preference repository. The view model then emits its effects through a shared flow, enabling reactive UI updates, such as showing error messages or navigating to the home screen. Similarly, let's update the sign-in anonymous event. When this event is triggered, it calls auth repository.signinAnonymous within a coroutine scope. The view model scope plays a crucial role here. This special coroutine scope in Android automatically manages the lifecycle of coroutines within the view model. It ensures that all launched coroutines are canceled when the view model is cleared, preventing potential memory leaks and simplifying asynchronous task management. Next, we'll update the sign-in screen composable by integrating the onboarding view model using Coin's dependency injection. The introduction of launched effect creates a robust mechanism for handling side effects, allowing the UI to reactively respond to state changes emitted by the view model's shared flow. We've refined the sign-in composable to accept a dispatcher function implementing a unidirectional data flow pattern. The Google sign-in button now dispatches an event.signin with Google event when successful, passing the credential to the view model for processing. Similarly, the guest sign-in button, which was previously used for navigation, now triggers an event sign-in anonymous event. These changes reflect a shift towards a more event-driven architecture, where UI interactions are translated into events that the view model can handle. All right, it's time to put our app to the test. We'll start by demonstrating the error scenarios for Google Sign-In. For this, we'll use an emulator that doesn't have Google Play services installed. When we try to log in, it will show the error banner that we created in our second video series. Next, let's try the anonymous login. If it is successful, we should see the entry appear on the portal. Now we'll move on to testing successful sign-ins and attempt to log in. If everything is smooth and functioning correctly, we should see our user entry on the dashboard. It's great to see both Anonymous and Google Sign-In working flawlessly. Learn how to create, manage, and integrate databases seamlessly into your Android applications using Room, Kotlin, and modern Android development practices. First up, we're going to build our app's brain, the database. We'll give it its own special home, aka a separate module to keep things tidy. Next, we'll enhance our design system by developing robust, reusable UI components. These components will provide a clean, intuitive interface for users to seamlessly add financial records and categorize transactions. Sounds great, right? Finally, we'll update the main and app modules to make everything work together like a well-oiled machine. Building on our previous work, we're now expanding our app's architecture. In this video, we'll introduce 4 new modules to enhance our application's structure and functionality. We'll create a dedicated database module to manage our local data storage, a data module for the records feature to handle data operations, and a domain module for records. In our previous video, we covered the process of creating modules, so we'll skip that detailed explanation this time. However, for those following along, here's a quick reference for the module names and package names you should use to stay in sync with this tutorial. Now let's dive into setting up our database. To integrate the database effectively, we need to update our libs.versions.toml file with some essential dependencies. We'll be incorporating Room KTX, Room Runtime, and Room Compiler for our database operations, crucial for seamless data management. To enhance our UI, we'll include the extended material icon library. Lastly, we'll add the KSP Kotlin Symbol Processing plugin to streamline our build process. KSP is a faster Kotlin native alternative to CAPT for annotation processing. It's needed to efficiently generate code for libraries like Room, significantly speeding up build times and providing better integration with Kotlin features. We'll start by applying the KSP plugin in our project-level build.gradle.kt's file. This sets the stage for efficient annotation processing throughout our project. Next, we'll create our database module, ensuring it's set up as an Android library module to maintain proper separation of concerns. Once the module is created, we'll open its build.gradle.kts file and make some crucial updates. In the plugin section, we'll include KSP. Additionally, we'll add the necessary dependencies for Room Database, Coin for dependency injection, and the Room compiler. Up next, we will create our entity data classes. Entities in Room are Kotlin or Java classes annotated with an entity that represent tables in the SQLite database. Each instance of an entity corresponds to a row in the table, with class fields mapping to columns, allowing you to define your database schema using object-oriented principles. We'll create an enum class called transaction type that defines two types of financial transactions, credit and debit. Next, we define a category entity data class, which represents a table in our SQLite database named categories. Each category entity has 4 properties: an auto-generated primary key ID, a name, an icon, and a type. The type property uses our previously defined transaction type enum, allowing us to associate each category with either credit or debit transactions. Following a similar pattern, we're creating a subcategory entity data class. This entity represents the subcategories table in our database. The category ID field is particularly important as it establishes a relationship between subcategories and their parent categories. Now let's talk about category with subcategories. This data class represents a category along with its associated subcategories, a powerful way to handle hierarchical data efficiently. It uses rooms at embedded and at relation annotations to establish a one-to-many relationship between a category and its subcategories. This allows us to efficiently retrieve a category with all its subcategories in a single query. Next, the transaction entity data class defines the structure for our transactions table in the database. It includes fields for transaction type, amount, category, and subcategory IDs, date, and notes, providing a comprehensive representation of each financial transaction in our app. Learning can be tiring, so take a moment to relax. Here's a quick joke for you before we progress ahead, because coding is better with a little fun. Now, grab some water, take a deep breath, and let's get back to coding. Next, let's understand the DAO, or Data Access Object. A DAO is a pattern that provides an abstract interface to interact with a database or other persistence mechanism. It separates the data access logic from the business logic, allowing for more modular and maintainable code. A clean, structured approach is always best, right? There are 3 major database operations: query, delete, and insert. Querying retrieves data from the database. Deleting removes records based on specified conditions. Inserting adds new data to the database. These operations form the foundation of data manipulation in databases. We also have transactions, which are sequences of one or more database operations treated as a single unit of work. Transactions ensure data integrity by guaranteeing that all operations within the transaction are completed successfully, or none of them are applied if an error occurs. This means no partial updates, no corrupted data, just pure consistency, exactly how a well-structured database should work. Next, we'll create an interface called Finance DAO, which serves as our data access object for database interactions. This is where all the magic happens when it comes to managing financial data efficiently. This interface defines a comprehensive set of methods for managing financial data, including inserting transactions, categories, and subcategories, all with a conflict resolution strategy. We've implemented query methods to retrieve all transactions and filter them by date range. Method to fetch categories and their associated subcategories using a @transaction annotation. Each method is designed as a suspend function, enabling seamless integration with Kotlin coroutines for efficient asynchronous database operations. The @database annotation in Room is used to define a database. It specifies the entities, version number, and other important properties to structure our database properly. Here's what it includes. Entities, list of entity classes that represent tables in the database. Views, database views, if any, defined as classes. Version, an integer representing the database version used for schema updates. Export schema, a Boolean flag to export the database schema to a folder. Auto migrations, defines automatic schema migrations between versions, smooth upgrades, right? Next, we'll create the abstract class finance database. This class extends Room database and is annotated with @database, specifying our 3 entity classes: transaction entity, category, subcategory entity, and we're setting the database version to 1, our starting point. The class declares an abstract function, finance DAO, to provide access to our finance DAO. This is where our DAO methods get connected to the database for real-world usage. A companion object includes a pre-populate database function, which uses coroutines to asynchronously populate the database with predefined categories and subcategories. This ensures our app has useful data right from the start. This function inserts categories and their associated subcategories, ensuring each subcategory is correctly linked to its parent category. Here's a quick look at Get Predefined Categories. We're just listing a couple of categories for now, but here's a brief category list we have. You can complete the code accordingly. We've used Unicode symbols, which you can easily find on websites like unicode.org and Emojipedia, making our UI visually engaging. Now, let's set up our Room database module using Coin for dependency injection. In this module, we're defining two single instances. One first single instance creates our finance database using Room's database builder. We're specifying the database class and naming it FinanceDB. We're also adding a callback to pre-populate the database when it's first created. Second single instance provides our finance DAO. It retrieves the DAO from the finance database instance we just created. Next, we'll shift our focus to the common module, where we'll define some essential data classes for transactions and categories. But before we dive into that, we need to update the buildgradle.kts file to include Kotlin serialization, which will help us with data serialization and deserialization. Now, let's create an enum class called record transaction type. This enum will have two values: debit, credit. These represent the two types of financial transactions we'll be tracking in our app. Moving on, we'll define a transaction data class. This class encapsulates all the necessary information for a financial transaction. Lastly, we'll create two more data classes: categorization and category. The categorization class represents a group of related categories, including the transaction type, a main category, a list of subcategories. Both these classes are marked as serializable, enabling easy conversion to and from various data formats. Next, we'll shift our focus to the design system module, where we'll create various UI components like tabs, calendars, and text fields. To get started, we'll need to add dependencies for material icons and our common model. Then we'll update the strings.xml file we created in the last video. Now, let's dive into the subcategory chip composable function. This nifty little UI component is like a digital button for our subcategories. It takes in icon, a selection state, an on-click function. The chip changes its background color based on whether it's selected or not, giving users a visual cue. It's styled with rounded corners and a border, making it look sleek and modern. Now, let's dive into the subcategories composable function. This function takes a list of subcategories, a callback function for when a selection is made. It sets up a scrollable row of subcategory chips, each representing a subcategory with its name and icon. As users scroll through and tap on these chips, the selected item is visually highlighted, and the onSelect callback is triggered with the selected subcategory's ID. Here is the quick preview of our component. Let's see it in action. Next. The tab item composable function is a custom UI component designed for creating selectable tabs in a Jetpack compose interface. It takes parameters for the tab's text, modifier, selection state, background color, and a click handler. The function creates a box with the specified background and shape, making it clickable. Inside this box, it displays the tab's text using a CW text component, with the text style changing based on whether the tab is selected or not. The animated tab composable function creates a customizable tab layout with smooth animations. It takes an array of tab labels and a callback function for handling tab selections. The function uses Jetpack Compose's state management to keep track of the selected tab and animates the background color change when a new tab is selected. The tabs are arranged in a row, each occupying equal space, and the selected tab is visually distinguished with a different background color. Let's have a look at the quick preview of the animated tab component. The select category composable function is a crucial UI element in our finance tracking app. It creates a clickable row that displays the current category type and provides a visual cue for selecting or changing the category. The function takes two parameters: one, category type, the currently selected category; two, On select category, a lambda function that's called when the row is clicked. The UI is structured using a row composable, which contains a column for text elements and an icon. The column displays a label for category and the current category type. The icon, styled as a circular add button, visually indicates that clicking will allow category selection or modification. Okay, here's the preview for the component. Next, we'll create two custom edit text composables. One, transparent edit text for our notes section. Two, amount edit text for entering monetary values. The transparent edit text composable is designed for inputting notes or additional information. It uses a basic text field wrapped in a column layout. The composable displays a label above the input field and shows a hint text when the field is empty. The amount edit text composable is specifically tailored for entering currency amounts. It also uses a basic text field, but with number-specific keyboard options. This composable handles the display of the currency symbol and formats the input as a monetary value. It changes color based on whether the amount represents income or expense. The composable also handles input validation, ensuring that only numeric input is accepted. It also provides a default value display when the input is empty. Both these composables demonstrate how we can create custom input fields that are both functional and visually appealing. The calendar text field composable is a custom input field for selecting dates. It combines Material 3 components with a date picker dialog to provide a user-friendly date selection experience. Let's break it down. First, we use Remember Savable to store the selected date in milliseconds, initializing it to the current date. We also have a Boolean state to control the visibility of the date picker dialog. A datetime formatter is created to format the selected date into a readable string. We use remember with selected date millis as a key to efficiently convert the milliseconds to a local date object when needed. The selectable dates object is defined to restrict date selection to past and present dates, preventing users from choosing future dates. Finally, we set up a date picker state using remember date picker state. This state manages the date picker's behavior, including the initial selected date, the range of selectable years, and the custom date selection rules we defined. A row that spans the full width of its container. Inside this row, we have two primary elements. One, a column for displaying the label and selected date. Two, an icon for the calendar symbol. It uses the calendar icon from the material icons set. The entire row is made clickable, and when tapped, it sets the show date picker state to true, which presumably triggers the display of a date picker dialog in the parent component. The date picker dialog is displayed when show date picker is true. It contains a date picker component for date selection along with confirm and dismiss buttons. The confirm button, when clicked, updates the selected date millis with the chosen date and calls the onDateSelected function with this value. The dismiss button simply closes the dialog without making any changes. Before we move to another module, we have a couple of things to update. We will make minor changes to our screen container so that we can change the color of the banner. If we want to show a success scenario, we will use the primary background and change the text accordingly. And next, we will add some more text types as displayed on the screen and adjust the color and style appropriately. Next up, let's move to our records domain module. Our domain module will have Android Core KTS and common modules as dependencies. Now let's take a look at the Update Finance Repository interface. This interface defines two key methods that our app will use to interact with our financial data. The first method, Save Transaction, is to save a new transaction to our data store. The second method, Get Categories with Subcategories, retrieves a list of categorization objects. The next Get Category use case class is part of the business logic layer in our app's architecture. It's responsible for fetching categories with their subcategories from our repository. It has a single method, invoke, which is called when the use case is executed. This method takes a Boolean parameter isIncome to determine whether we're looking for in-credit or expense debit categories. It then filters the categories based on this parameter, returning only the relevant categories. Next up, The getDefaultCategory use case class has a single method, invoke, which is marked as a suspend function. This allows it to be called from within coroutines. The method takes a Boolean parameter isIncome as well, then fetches all categories with their subcategories. We then filter this list and return the first category that matches our criteria. Moving to our data layer, we need to include the domain and database dependencies in our build.gradle file. Now, let's look at the Update Finance Repository impl class. This class implements the Update Finance Repository interface and is responsible for saving transactions to our database. It takes a finance DAO as a parameter, which it uses to interact with the database. The SaveTransaction method takes a transaction object and converts it into a transaction entity before saving it to the database. The getCategories with subcategories method retrieves categories and their associated subcategories from the database. It includes a retry mechanism that keeps checking for data if the initial query returns empty, ensuring we always have data to work with. Once the data is fetched, the method transforms it into a list of categorization objects. Next, we will create a module called Records Data Module. First, a single instance of Update Finance Repository impl and binding it to the Update Finance Repository interface. Next, it's time to add our UI. Include the design system, domain module, coin, and compose-related dependencies. Now, let's take a look at a useful extension function for Flow that we've used before in our Gmail mock series. This function, called stateInWhileActive, converts a flow into a state flow with some added functionality. It allows us to perform a prefetch operation before the flow starts emitting values, and it uses a while-subscribed sharing policy with a 5-second timeout. This approach helps optimize our app's resource usage by keeping the flow active only when there are active subscribers, with a short delay before shutting down to handle brief configuration changes. Next, let's look at 3 important sealed classes. We have the Finance Event Sealed class. This class defines different events that can occur in our app. Next, we have the Finance Effect Sealed class. This class represents the side effects or outcomes of our app's actions. For example, it can indicate when categories have been updated or when we need to show a success message to the user. Lastly, we have the Finance UI State Sealed class. This class represents the different states our UI can be in. It starts with an initial state and can transition to a categories loaded state when the app has fetched the category data. The Records View Model class is responsible for managing the UI-related data and business logic for our finance records. It uses a repository for data operations and a use case for fetching default categories. The view model exposes state and effects through state flow and shared flow, respectively, and processes various events to update the UI state or trigger side effects. The Update Categories function is triggered by an Update Categories event. It uses a coroutine to fetch categories based on whether it's income or not, then emits a Categories Updated effect with the result. The Load Categories function is similar, but instead of emitting an effect, it updates the UI state with the loaded categories. Lastly, the Save Transaction function saves a transaction to the repository and emits a success message as an effect. Next, we're creating a single instance of getDefaultCategory use case. Then we're setting up a view model factory for Records View Model, injecting the necessary dependencies. Add Record screen serves as the main screen for adding financial records in our app. It takes several parameters, including a view model, default currency, categorization data, and callback functions for various actions. The function uses Jetpack Compose to create the UI, collecting state updates from the view model and responding to effects. Depending on the current state, it either displays the main record-adding interface or a loading indicator. The UI is structured as a scrollable column with specific padding and spacing. This layout will serve as the foundation for our record entry form, where we'll add more components to capture transaction details. We're using Jetpack Compose's state management to keep track of various pieces of information, like the transaction amount, whether it's income or expense, notes, subcategory, and date. Then we add the row, which has the title of the screen and the close button. We use horizontal arrangement as a space between. Then we add the animated tab, which we have created. Whenever we switch the tab, we will dispatch an event update categories. Next, We will add the amount edit text and update the amount value whenever the user types in anything. We will then display the select category row, which we have created, and on click of the category, we will navigate to a different screen. Subcategory section goes next. We will give the subcategories list as the parameter. We then add the calendar text field, and whenever the user selects any date, we will get the date in milliseconds and update. Then to add the notes related to the transaction, we will add the transparent edit text. We will provide the label and hint to be displayed, and once the user changes the note, we will get back the value and store it. Finally, we add the button. On click of the button, we will dispatch the event Save Transaction. Here is the quick preview of the screen. Next, we will create the MVI contract for our transaction category screen. First, we have transaction category event, a sealed interface with an initialize event. This event is used to kick off the process of loading categories. Next, we have UI state, which represents different states our UI can be in. And finally, side effects that can occur in our app. Let's take a look at the transaction category view model class. This view model is responsible for managing the UI state related to transaction categories. It uses a get category use case to fetch categories and exposes a state flow for the UI to observe. The view model also processes events, such as initialization, which triggers the loading of categories based on whether it's an income or expense transaction. We're defining a module called Transaction Category Presentation Module. This module is responsible for providing dependencies related to transaction categories in our presentation layer. This function is responsible for displaying a screen where users can select a category for their transaction. It uses a view model to manage its state and events, and it takes parameters for handling income-expense differentiation, category selection, and navigation. The function uses a launched effect to initialize the view model when the screen is first composed, and then it observes the view model's state. Category composable function is responsible for displaying a list of categories and allowing the user to select one. It takes 3 parameters. The UI is structured as a column with a header row and a scrollable list of categories. The header includes a back button and a title. Next, the category item row composable creates a clickable column that contains a row with an icon and the category name. The icon is displayed in a circular box with a border, while the category name is shown next to it using a custom CW text component. We will take a quick look at the preview of the composable. Before we can see our app in action, we need to make a few changes in the previous module which we created. First, we need to update the main presentation Gradle file where we add the records presentation module. Next, we need to update the destination. We will create 2 new destinations. 1, add records. 2, select category. We will need to adjust our CW composable to accept content composable, which can take a nav backstack entry. We need this for sending and receiving data between different screens in type-safe navigation. Next, update the navigate to onboarding to go to add records destination instead of home. We will be creating that in the next video. Next, we add the select category composable screen. It takes an isIncome parameter to determine whether we're dealing with income or expense categories. When a category is selected, it's encoded to JSON and stored in the previous backstack entry's saved state. This clever approach allows us to pass data back to the previous screen when we navigate back. Next, we start by creating a mutable state variable to hold our expense categorization. Then we use a launched effect to listen for changes in the navigation backstack. When a change occurs, we check for a specific key in the saved state handle. If we find a JSON string there, we decode it into a categorization object. Finally, we call the add record screen composable, passing in various parameters. Next, we will quickly update the app module with the required dependencies as shown. And last, update the app module as well. Let's run our app and see how it's behaving. We will quickly inspect our database and validate if the category and subcategory are added in the database, and also if the transaction has been recorded successfully. Okay, step by step, you'll learn how to bring your data to life and build amazing visualizations for your Android apps. In this final episode, we're tying everything together to create a fully functional budgeting app. Here's what's on the agenda. First, we'll implement a sleek bottom navigation bar, making it easy for users to switch between key sections effortlessly. Next, we'll focus on the transactions screen, where users can view and manage their finances. We'll also add smart filtering options to help them quickly find specific transactions. Then comes the analytics screen, the real game changer. We'll integrate the charts we built with Jetpack Compose to visualize spending habits in a clear and insightful way. Finally, we'll wrap things up by building a settings screen, giving users control over their app preferences. All right, let's jump into the code. First, we need to update our dependencies in the libs.versions.toml file. We're also defining a new version for Coil, a powerful image loading library for Android. Next, we need to integrate these libraries into our project by adding them to the design system module's build.gradle file. In today's world of diverse devices, designing for multiple screen sizes is a must. Whether it's a phone, tablet, foldable, or even a multi-window setup, your app should look great everywhere. Luckily, Jetpack Compose makes this easy. It uses window-size classes to categorize screen space into compact, medium, and expanded, allowing us to create responsive layouts effortlessly. Check out how our Cashwise app adapts to different devices. On compact phones, we stack income and expense graphs vertically for better readability. On foldable devices, we leverage the extra space to display them side by side, making the most of the wider screen. This code defines a window type sealed interface along with a remember window size composable function to dynamically determine the current window size based on screen width. It also creates a composition local window type to provide this window type information throughout the app. Here's how the classification works. Compact. If the screen width is less than 600 dp, it's categorized as compact. This typically includes smartphones in portrait mode. Medium, screens between 600 dp and 839 dp fall into this category. This might include larger phones in landscape mode or smaller tablets. Expanded, any screen 804 dp or wider is considered expanded, covering large tablets, foldables, or desktop-like experiences. Move to your theme class and update it. We're using Composition Local Provider to make window size information available throughout the entire app. Now let's talk about bar charts. A bar chart is a powerful tool for visualizing data, using rectangular bars to represent different categories or values. The length or height of each bar corresponds to its value, allowing users to quickly compare data at a glance. All right, let's break down the math behind our bar chart. We start with our data list, which is simply a collection of numbers. These numbers could represent expenses or income in our app. To properly scale our chart, we first identify the highest value in the data set. For example, if the maximum value is 20, this serves as a reference point to ensure our chart displays all data proportionally. Next, we set a fixed maximum height for the chart, which in this case is 200 dp. Once the maximum value and chart height are defined, we calculate the height of each bar. The formula takes the data point, divides it by the maximum value, and then multiplies it by the maximum chart height. This ensures that each bar is scaled correctly while keeping proportions intact. Additionally, by applying a safeguard that prevents any value from being too small, we make sure that even minor data points are still visible on the chart. To efficiently manage our financial data, we use a monthly data class. This class bundles together key details such as the month's label, total income, and total expenses. To visually represent this data, we create a bar item composable, which acts as an individual bar in our chart. This composable takes in a monthly data object, a maximum value for scaling, and a selection state to highlight specific bars. The layout consists of a column structure within a box, and the label appears below it. Inside the box, we further divide the bar into two sections to differentiate between income and expenses, both proportionally scaled relative to the maximum value. To maintain a consistent design, we use our custom CW text component to display the month's label, ensuring clarity and readability. Now, let's talk about the overall structure of our bar chart. In our Cashwise app, the bar chart composable is responsible for creating a dynamic and scrollable visualization of monthly financial data. This component allows users to interact with the chart, highlight specific bars, and analyze trends. The chart includes a vertical axis for labeling values. The range of values extends from 0 to the maximum financial value in the dataset, and it is divided into 4 equal intervals. This structured approach ensures that the scale is well distributed, making it easier for users to interpret the data at a glance. Finally, we implement a horizontally scrollable row of bar item components, where each bar represents a specific month's financial data. This scrolling functionality allows the chart to accommodate large data sets, and just like that, we've raised the bar. A line chart is a powerful way to visualize trends over time by connecting data points with straight lines. It consists of an x-axis, which typically represents time, and a y-axis, which represents the measured value. By plotting the coordinates of each data point and connecting them, a line chart effectively illustrates patterns, relationships, and fluctuations in data. To mathematically construct a smooth and scalable line chart, we start with a list of data points. These values represent the measurements we want to display in our chart. The first step is to determine the maximum value in the dataset. For example, if the highest value is 90 on a Friday, this helps us properly scale the y-axis so that all points fit within the chart. Next, we calculate the x-axis step size to ensure that each data point is evenly distributed across the chart's width. This guarantees a well-proportioned layout, regardless of the number of data points. To fit all values within the available height, we introduce a scale factor by dividing the total chart height by the maximum value. This allows every point to be plotted within the designated space while maintaining accurate proportions. Once scaling is in place, we can convert raw data points into coordinates. The status x coordinate is determined by multiplying the data index by the step size, while the y coordinate is calculated using the scaled value. Since screen coordinates on devices start from the top left corner, we subtract the scaled value from the total chart height to correctly position points from bottom to top. At this stage, we have everything needed to create a basic line chart. However, to enhance its visual appeal, we introduce midpoints between adjacent points. Instead of using sharp connections, we apply a quadratic Bezier curve to create smooth transitions between data points. This results in a fluid, natural-looking line chart rather than one with jagged edges. Now let's talk about how this is implemented in our line chart composable. This component is responsible for visually representing a list of expenses as a smooth flowing graph. The chart is drawn inside a canvas with a fixed size of 100 by 50 dp, ensuring it fits well within the app's layout. The first step in rendering the chart is normalizing the data. We identify the highest expense to scale all values proportionally within the available height. The step size on the x-axis determines the horizontal spacing between points, while the scale factor for the y-axis ensures that higher expenses appear correctly positioned at the top of the chart. Each expense value is then converted into its respective x, y coordinate, setting the foundation for drawing the line. To create a smooth curve, we begin at the first data point using a path function. From there, we loop through the remaining points and apply quadratic Bezier curves to ensure smooth transitions. Once all points are processed, the drawPath function renders the curve onto the canvas using the specified color and a stroke width of 3dp. Now we can literally see our money going up and down, hopefully more ups than downs. A pie chart is a circular graph divided into slices, where each slice represents a proportion of the whole. The size of each slice is determined by either its percentage or numerical value in relation to the total data set. This type of chart is especially useful for visualizing the distribution of categories within a data set, making it easy to see which categories contribute the most or least to the whole. To construct a pie chart, we start with a char list of numerical data points. The first step is to calculate the sum of all values in the data set, which in this case totals 255. This sum allows us to determine the proportion of each value. Using the formula that divides each value by the total sum and multiplies it by 360 degrees, We can convert each data point into its corresponding sweep angle, defining the size of each slice within the chart. To maintain a structured and intuitive layout, we set an initial start angle of 90 degrees, positioning the first slice at the 12 o'clock mark. To enhance readability, we introduce a gap angle of 12 degrees between each slice. This small separation prevents the segments from blending together, making it easier to distinguish between different categories. The drawing process follows a structured sequence. We start at the current angle, draw the slice using its adjusted sweep angle, subtracting the gap, and then update the start angle for the next slice. This approach ensures that each slice is correctly positioned and spaced within the circular graph. Now let's talk about how this is implemented in our code. We use a PyData data class to represent each slice in the pie chart. This class contains important details such as the category name, associated icon, color, and numerical value. The pie chart composable is responsible for creating an interactive and visually appealing circular chart that represents expense categories. Inside this composable, a canvas is placed within a box to draw each segment of the pie chart. To determine the correct size of each segment, we compute a sweep angles list, which converts each expense amount into its proportional representation out of 360 degrees. Then inside a loop, each segment is drawn using the drawArc function. To make the chart visually engaging, we apply a rounded stroke effect to the segments. Each slice is also assigned a unique color, parsed from its string representation, ensuring that different expense categories are easily distinguishable. At the center of the chart, we display the total expense amount, formatted as currency, along with a label. This provides users with an at-a-glance summary of their total spending while still allowing them to see the breakdown by category. A circular Venn diagram is a visual representation that uses overlapping circles to illustrate relationships between different sets of data. Unlike a traditional pie chart, which divides a circle into distinct slices, a Venn diagram focuses on intersections, showing how different categories relate to each other. To create our circular Venn diagram in the Cashwise app, we adapt the same arc drawing approach used in our pie chart, but introduce a key difference in positioning. Instead of drawing static slices, we arrange overlapping circles with varying radii. The process still involves calculating sweep angles and using the drawArc function to create arcs, but instead of keeping all segments within one confined space, each subsequent circle expands outward. To determine the size of each circle, we start with a base radius, which is defined as 1/4 of the screen width. For each additional circle, the radius gradually increases, ensuring a layered and proportional distribution. To structure the data efficiently, we introduce a new data class called CircleGraphData. This class contains 3 key parameters. For rendering arc-shaped indicators, we use a custom drawing function called drawIndicator. This function operates within drawScope and is designed to create partial circular segments. Instead of filling the entire circle, drawArc is used to render only the desired portion. The start angle controls where the arc begins, while the sweep angle determines how much of the circle is drawn. To keep the arcs perfectly centered, we calculate the top left offset based on the center coordinates. To enhance the visual appeal, we apply a stroke with a rounded cap. Several key variables play a role in positioning, sizing, and distributing the segments accurately. The X and Y coordinates of the center are calculated by halving the canvas width and height, ensuring that the diagram remains perfectly aligned. The radius of the indicator is set to 1/4 of the screen width. To ensure proper scaling, the largest data point in the dataset is identified as a reference. The dataset is also sorted in ascending order, allowing smaller values to be drawn first, ensuring that larger values do not overshadow smaller ones. Additionally, animation progress is incorporated, allowing smooth transitions when updating the chart. To finalize the design, we draw 2 indicators, one for the background circle and another for the foreground circle. This layering effect enhances depth and clarity, making it easier for users to interpret overlapping relationships within the dataset. With everything in place, we now create the Venn chart composable. To manage animations, we use Animatable, which enables smooth transitions when data updates. Each time the dataset changes, a coroutine is launched inside Launched Effect, resetting the animation to 0F and gradually progressing to 1F over 1,000 milliseconds using a tween animation. To ensure adaptability across different screen sizes, the screen width and height are dynamically calculated. The height is determined by dividing the width by a scaling factor, maintaining consistent proportions on different devices. Finally, we use a column layout to center the diagram and apply the draw behind modifier to render the pi indicator in the background, ensuring a structured and visually balanced appearance. With that, our circular Venn diagram is ready to go. Let's continue our journey as we dive deeper into building more dynamic and interactive components for our Cashwise app. To get started, we'll define two essential model data classes, progress bar data and income expense data. Now meet the progress bar composable, a sleek and intuitive way to visualize progress within the app. This composable takes in three key parameters. The first is progress, a float value ranging from 0f to 1f. Next, we have progress background, which sets the background color. Finally, we define progress foreground, which determines the color of the filled portion. The magic behind this component happens through the use of two nested box elements. The outer box acts as the full progress bar, stretching across the screen with a fixed height and smooth rounded corners to maintain a polished look. Inside this outer box, we have the inner box, which dynamically expands based on the progress value. With these foundations in place, we're well on our way to creating even more visually engaging components. Let's keep going. Next up, the spending item composable is like a mini financial tracker that helps you see how much you've spent in a particular category compared to your highest spending. It works by first calculating how much of the total spending this category represents. To make sure the value doesn't go too high or too low, it is kept within a safe range so that it always fits properly in the progress bar. To make the experience smooth, the progress bar is animated. Instead of jumping instantly to the new value, it gradually moves over 1 second, creating a nice transition effect that feels natural and polished. For the layout, everything is neatly arranged inside a column. The first row shows the category name on one side and the spending amount on the other, making it easy to read at a glance. Below that, the progress bar fills up based on how much has been spent in that category. Each category also gets its own color, making it visually clear and easy to distinguish. Here's a little preview of how it will look in the app. These two extension functions bring smart color logic to your UI, ensuring the right colors are applied automatically based on transaction types. The getTextColor function makes it easy to distinguish between debits and credits by assigning different colors, while AmountColor dynamically adjusts colors based on a Boolean value. This makes the interface more intuitive and visually clear. Moving on to Legend Item, this composable acts as a tiny color-coded label that pairs a colored box with a text description. This helps users quickly understand different chart categories without any confusion. The category chip composable takes this a step further by creating a stylish, rounded chip with a color-coded label. It includes a soft border, smooth background, and proper spacing to keep everything looking modern and clean. To make it even better, it uses Legend Item to display a small colored indicator alongside the text, keeping things visually consistent. Next, we have CW Card, a sleek, reusable card component that wraps UI content in a well-styled, rounded background. With built-in padding and a polished look, it ensures that any content inside appears structured and professional. Just drop in your composables and CW Card will handle the aesthetics effortlessly. Now, let's bring all these card components together in our Cashwise app. One of the most exciting additions is the Finance Card, which beautifully displays total income or expenses over the last 12 months. It calculates the total, applies dynamic coloring using amount, and presents the final value in bold, easy-to-read text. To make financial insights even clearer, a smooth line chart sits beside it, visually representing trends and helping users quickly spot patterns in their spending or income. The Spending Bar Card composable provides a clear and organized breakdown of spending for a given month, making it easy to see where your money is going. It sorts the spending data, identifies the highest expense, and scales each spending item dynamically to ensure the progress bars accurately represent proportions. Everything is neatly wrapped inside a CW card, giving the chart a polished and structured look. Income expense cards composable takes adaptability to the next level. On smaller devices, it stacks income and expense cards vertically to fit the layout, while on larger screens, it arranges them side by side for better readability. The Circle Income Card Composable offers a clear visual breakdown of monthly earnings, making it easy to track income sources at a glance. On compact screens, it neatly stacks a Venn chart alongside a scrollable category list, while on larger screens, it lays them out side by side for better organization. The monthly bar card composable brings monthly financial trends to life by allowing users to visually compare income and expenses with ease. It features a dynamic bar chart where tapping on a bar instantly selects a month, updates the UI, and triggers an action with the selected month's label. To make things even clearer, color-coded legend items sit above the chart, making it effortless to distinguish between income and expenses at a glance. The balance card composable provides a quick snapshot of your current balance, combining essential financial details in a clean, structured layout. It prominently displays the formatted balance amount, along with a details button that allows users to explore their finances further. To make goal tracking more intuitive, a progress bar below visually represents progress toward a financial milestone, helping users stay on top of their financial journey. Now that all our cards are complete, let's take a moment to preview everything and see how they come together in our app. The transaction category icon, composable, neatly displays a category icon inside a stylish, well-structured box. It dynamically scales its size using Get Scale Factor SAW, ensuring the icon adapts perfectly to different layouts. The icon sits inside a bordered, rounded container with a theme-based background color. Inside the box, the icon itself is displayed as text. The transaction item composable is responsible for presenting a transaction entry in a structured row layout. It starts with transaction category icon, followed by a column displaying the category name and subcategory using CDW text. On the right, the transaction amount is shown with a dynamically assigned color, making debits and credits easily distinguishable at a glance. The filter button composable creates a rounded, selectable button designed for filtering transaction types. It features a bordered and clipped row with a dynamic background color that changes based on whether it's selected or not. When tapped, it triggers On Filter Selected, Store Style, updating the filter selection. Inside the button, the text is displayed using C to W text, ensuring consistency with the rest of the UI. To bring everything together, the filter row composable arranges a row of filter buttons, allowing users to select different transaction types effortlessly. It maintains a selected filter state, updating in real time whenever a button is clicked. As users toggle between filter buttons, the On Filter Selected callback is triggered, ensuring a seamless and responsive filtering experience. Now, let's bring the bottom navigation bar to life. First, we'll create a data class to store the icon, label, and index for each navigation item. The bottom nav bar composable sets up a navigation bar with 5 items, each represented by a bottom nav item data containing its index, label, and icon. The items list is remembered, preventing unnecessary recompositions and keeping performance smooth. The layout is handled with a row, ensuring all navigation items are evenly spaced for a clean and balanced appearance. To make things interesting, there's a special condition for the third item in the navigation bar. Instead of a regular button, it displays a floating action button with a plus icon, styled using the primary theme color. For all other navigation items, a regular navigation bar item is used. The icon color dynamically changes, with the selected item appearing in primary color and unselected items using on-surface color. Now, onto the search bar composable. This component provides a clean and intuitive search experience. It maintains a search query state, updating in real time as the user types. The UI is wrapped in a box with rounded corners, keeping it visually sleek. Inside, a row aligns the search icon and input field, ensuring everything is properly positioned. The basic text field updates the query and triggers on value change, allowing the parent composable to react instantly to input changes. If the field is empty, a helpful placeholder, Enter Transaction Name, appears, guiding the user. The settings item composable creates a simple, clean, and clickable row For a settings option, it neatly displays a title using CW text and an arrow icon, making it clear that tapping the item will navigate to another screen. With arrangement.space between, the text and icons stay properly aligned, creating a balanced and visually appealing layout. When tapped, it triggers on-click, ensuring smooth and responsive navigation. Similarly, we'll create a notification item composable, but instead of an arrow icon, it features a toggle switch. This allows users to easily enable or disable a setting right from the row. Now, let's take a quick preview of all the amazing components we've built. Expanding our modules, setting up the dashboard. Building on our previous module, we're now setting up the dashboard data domain and presentation module. Here's a quick overview of the module and package names we'll be using. Before diving into the remaining screens, we need to do a bit of pre-work by adding some essential data classes and extension functions. To make financial data user-friendly, we introduce format as currency, an extension function that formats any number as currency with up to 2 decimal places. Another handy function, to date format, converts a long timestamp into a properly formatted date string using either a short or long format, depending on the user's needs. For filtering transactions, the filter type enum helps categorize them as income, expense, or none, making filtering straightforward and efficient. Additionally, the analytics data and dashboard data classes store key financial insights such as income, expenses, monthly trends, charts, and recent transactions, setting up the domain module and writing business logic. Before we dive into the business logic, let's set up our domain module properly. First, we need to include the common module and Android Core KTX dependencies in the domain module. In the data module, we'll be working with the dashboard domain and database module, which we created in the last video. Moving on to the presentation module, we'll add the required dependencies for Coin, Jetpack Compose, and the domain module. And yes, don't forget to add the Compose plugin to keep everything Compose ready. Now that our domain module is configured, it's time to write the core business logic for handling transactions and analytics. The dashboard repository interface defines a suspend function, getTransactions, which asynchronously retrieves a list of transactions. This serves as the data source for the use cases that follow. The getTransaction use case class fetches transactions from dashboard repository and applies filters based on filter type. Income returns only credit transactions. Expense returns only debit transactions. None returns all transactions without filtering. Next, the getAnalytics data use case processes transaction data to generate financial insights. When executed, it retrieves all transactions and separates them into credit transactions, income, and debit transactions, expenses. It then calculates total income and total expenses by summing the respective amounts. To structure financial trends, transactions are grouped by month using their formatted dates. For each period, it calculates total income and expenses, then maps this data into monthly data objects, providing a structured monthly financial summary. For income analysis, transactions are grouped by month and category name to generate circular income chart data. Each category's total amount is calculated and a circle graph data object is created. For expense tracking, transactions are grouped by month and category name to generate bar chart data. The total expense amount for each category is calculated, assigned a category name and color, and stored as progress bar data. The data is then sorted in descending order, ensuring that the highest spending categories appear first in the bar chart. Finally, all these insights are combined into an analytics data object, which is then returned, providing a comprehensive financial overview for the user. The Get Dashboard data use case is responsible for fetching transactions from dashboard repository and calculating key financial insights. It determines the total income, total expenses, and current balance, giving users a quick overview of their finances. Additionally, it extracts the 5 most recent transactions, ensuring that the dashboard always displays the latest financial activity at a glance. For pie chart data, the use case filters out expense transactions, debit, and groups them by category. It then calculates the total amount spent per category and extracts important details like the category name, color, and icon. These are mapped into pie data objects, making it easy to visualize spending patterns. Finally, all this information is packaged into a dashboard data object and returned. Moving to the data module, the dashboard repository impl handles fetching all transactions from the Finance DAO database. It then maps them into transaction objects while correctly identifying their type as credit or debit. To ensure that the most relevant data is always at the top, transactions are sorted by date in descending order. To tie everything together, the dashboard data module is created as a coin dependency injection module. It includes the room module for database setup and provides a singleton instance of dashboard repository impl, binding it to the dashboard repository interface. Now, let's move on to the presentation module, where we define the MVI contract for the home screen. We start with the home UI state data class, which holds everything needed for the home screen. To handle events, we define the home event sealed interface, where load data serves as the trigger for fetching and updating dashboard data. The home view model is responsible for managing the UI state of the home screen. It uses mutable state flow to store the current home UI state and exposes a read-only state flow, ensuring that the UI can observe changes without modifying the data directly. When process event home event.load data is triggered, the magic happens. The function calls load data sign, which launches a coroutine in view model scope, fetches the dashboard data from get dashboard data use case, and updates the state accordingly. This ensures that the dashboard is properly populated, the loading indicator stops, and a quick check determines whether transactions are available. Building the home composable. Inside the home composable, we start collecting the UI state and use launched effect to trigger process event home event.load data, ensuring data is loaded as soon as the screen appears. We then define a scrollable column to structure the layout. At the top, we display a welcome header, followed by the balance card we created earlier in this video. Next, we check if pie data is available from the use case. If it exists, we display the expense pie chart, making it easy to visualize spending patterns. Similarly, we check if recent transactions are available. If they are, we display them inside transaction item components for quick access. If no data is available, we show a friendly message, no transactions available. To encourage users to get started, we also add a button that allows them to add their first transaction effortlessly. Here's how it looks. When data is available, notice how categories appear on the left in expanded screen sizes, ensuring a clean and structured layout. When there's no data, the UI gracefully adapts, displaying an empty state message along with an action button. Now, let's move on to creating the transactions. Defining the MVI contract first. We quickly define the MVI contract for the transaction screen. We have 4 event types. 3 for filtering transactions, 1 for loading all transactions when the screen is launched. Next, we set up the transaction view model, which takes get transaction use case as a parameter. Whenever process event is called, it invokes load transactions with the appropriate filter type, ensuring the UI updates with the correct set of transactions. The transaction screen composable observes the transaction state from transaction view model using collect as state with lifecycle. When the screen is first launched, it triggers transaction event.load transactions to fetch and display transaction data. Inside the column layout, we arrange the main UI components. A header with a download button for exporting transaction data, a search bar to allow quick searching of specific transactions, a filter row, enabling users to switch between all transactions, only expenses, or only income. When a filter is selected, it calls transaction view model to reload the data with the chosen filter, updating the UI instantly. Once data is loaded, transactions are displayed inside a lazy column. Transactions are grouped by date, with each section starting with a sticky header that shows the formatted date, making it easy to distinguish transactions from different days. Inside the lazy column, we iterate through the list of transactions, displaying each one using transaction item, ensuring a structured and user-friendly view. Here's a quick preview. With this setup, the transaction screen is clean, intuitive, and easy to navigate. Users can filter, search, and view transactions effortlessly. To start, we define setting type, which allows us to display 3 different types of views: title headers, settings items, and switch items. The settings view model is straightforward. It simply sends a list of setting type items as part of the initial UI state. No complex logic here, just a clean way to manage and display settings. Inside the settings screen composable, We use a lazy column to list all settings options. The UI dynamically renders headers, clickable items, and switches based on setting type. It observes the settings state from settings view model, ensuring any updates are instantly reflected in the UI. This makes it easy to navigate and customize user preferences. Moving to the final screen. Analytics. For the analytics screen, we first define the MVI contract to structure our state and events properly. Since we've already built multiple screens following the same approach, the analytics view model will feel very familiar. So instead of lingering on repetitive setup, we'll move quickly to the fun part, building the actual screen. The analytics screen stacks all the financial cards we created earlier inside a scrollable column. This ensures that users can effortlessly navigate through key financial insights, including income trends, expense breakdowns, and spending patterns all in one place. We have everything in place, but before we hit that run button, we need to do some final integrations to make sure our app works smoothly. First, we'll create the coin module to manage dependencies, but by now, I'm sure the code is pretty self-explanatory, so we won't dwell on it too much. Next, we need to add the dashboard module dependency in the main presentation module and ensure that the dashboard module is properly included in it. For navigation, we'll define the destinations for all 4 screens and ensure they are serializable, allowing us to pass data between screens easily. As part of the final cleanup, we'll refactor the existing implementation of CUApp. This involves removing the highlighted code and instead moving the add record screen and transaction category composable into the appropriate module. With this change, Navigate to Dashboard will now have only one composable to load, authenticated home screen. Inside authenticated home screen, we'll use a scaffold layout to manage the bottom navigation bar. Based on the selected index, it will dynamically load the appropriate screen, ensuring smooth navigation across the app. It's time to run the app. And that's a wrap. This was the final part of our series, and we can't thank you enough for all the love and support along the way. We hope you learned a lot and had as much fun as we did. If you enjoyed this journey, make sure to like, subscribe, and share it with your friends. More awesome content is on the way, so stay tuned. To get the complete code and support us, check out the link in the description. Until next time, happy coding.